might be where you are. Thank you so much for joining us for this search and matching in macroeconomics and finance workshop on inflation. We're very excited today to have an excellent program for you guys. Excuse the typo, the break won't be starting for another hour, as we'll be hearing from Yang Lu talking about the rise, fall, and stabilization of US inflation. And we also very briefly want to direct your attention to our upcoming schedule. We'll be very excited to have Giorgio Piacentino from Columbia University presenting in our seminar on September 12th, and then Fernando Alvarez on October 10th. And I would also like to very quickly go over the ground rules here. We're trying to port the live in-person seminar atmosphere into the virtual space as much as we can. So please feel free to unmute yourself and interrupt the speaker with polite, concise, and to-the-point questions. Active discussion is the point. If the speaker feels that their time is better spent deferring questions to the end of the to the discussion after the talk, then of course that's the speaker's privilege. And as the moderator, I might also ask you to keep your questions for later if we have too many. And that's all I want to say. And well, you're here to hear from Yang. So Yang, please go ahead.
Okay. Thank you very much. Let me share my screen. So first of all, thank you very much to have us on the program. I'm Yang Lu from HKUST, and this is a joint work with Bob King from BU. And Bob is a longtime collaborator, and he is also in the audience today with us. So managing expectation is central to central bank's inflation policy. Central bank often communicates to the market about its intended inflation, output, sometimes future policy rate. Market also responds to these communications with their forecast revision. All these are backed by macro theory that often portrays central bank as a dominant player with strategic power over market expectations. And those strategic power derives from the central bank's commitment capacity. So in this paper, we ask, what if the market or the private sector is skeptical about central bank's commitment capacity? In particular, how does this skepticism affect the policy choice by the central bank? To answer that, we need to be a bit more specific about the nature of private sector skepticism. We need to ask, what other policies do private sector think can occur, and whether and how the committed central bank can affect these perceived alternative policies? And second, what is the private sector's likelihood of this alternative policy occurring, and whether or how the committed policy maker can affect that likelihood? So to answer these questions, we provide a theory, and we test our theory in the sense of Prescott using the US inflation experience. So before I go to talk about our theory, I want to first establish some basic features of US inflation experience. The first important feature we think is there are different monetary regimes over the past decades. So here is a plot of US inflation starting from 1950s all the way to 2005, and of course we can go on. But just with this few decades, we can see that it starts with a low and stable inflation up to the mid-1960. And then the 1960 to the 1980 is a famous great inflation episode, followed by Volcker disinflation regime, and then leads to the great moderation under Greenspan. So this is our first feature. There's regimes. The second basic feature we think that are important is there appears to be private sector learning. What make me say that? So this is a plot of, again, the US inflation data, and now plotted together with the inflation forecast data coming from the SPF collected by the Philly Fed. And you can see that the difference between the actual inflation and the forecast inflation is the forecast error. And if you look at the forecast error, which is plotted in the dashed line, and appears there are lengthy runs of persistent positive and negative forecasting error. Not only these errors are persistent, but it appears there are persistently positive forecasting error before 1980, and after 1980, there appears to be persistent negative forecast error. So we're not the first to document this phenomenon, and actually appears in several earlier papers. And one of the explanation this author proposed is private sector learning. So in this paper, we're going to take this seriously. So our model incorporate the regime change and private sector learning, and we're introducing other highlight in our feature. So we have random regime switch, and the regimes are two possible, are featured with two type of possible policymaker. One type, we call that committed type, and this committed type can manage inflation expectations. There's another type we call opportunistic type. That type cannot commit, but that type is also choose inflation optimally, responding to the inflation expectation. So we assume that these policymakers set their intended inflation depending on the state of economy, but the actual inflation outcome is a random outcome based on this intended inflation. And our private sector in the model are learning about which type of policymaker they're facing by observing this actual inflation outcome. And then their belief on how likely they're facing a committed type is what we call reputation. And this is going to be a key endogenous state in our model. And lastly, I want to emphasize we have a standard new Keynesian-Phillips curve with forward-looking expectations, in the sense that our expectation is on the future inflation, which gonna incorporates the private sector learning, and this perspective regime changes. So our theoretical contribution is we propose a mechanism design approach to solve the model equilibrium in a recursive fashion. And then what we do with this model is we take it to the data, and we propose a method to extract latent state identified by our recursive method from the inflation forecast data. In particular, a 1 quarter ahead forecast and 3 quarter ahead forecast. And then we use this extracted latent state as input to compute our model implied time series. And then we test our how well the extracted latent state work by comparing this model implied time series with some untargeted time series in the data. So we actually check whether our model implied inflation forecast can match the untargeted 2 quarter ahead and 4 quarter ahead SPF. We also check whether our model implied policy, optimal policy, can match the US actual inflation. So what we find is our model implied opportunistic policy can track US inflation before 1981, and our model applied optimal committed policy can track the US inflation after 1981. Just to be upfront, we show our model has explanation power of US inflation experience, but we did not show that other explanations are not possible. So it's not a horse race among several models. And our framework is also set up for formal econometrics work, but we didn't do econometrics in this paper. This is left for future research. It's a calibration exercise. Just to give you a preview about the claim I just made, our model implied policy tracks US inflation. So here I show you the red line, which is our model implied opportunistic policy. And you can see, compare that with the dashed line, which is actual inflation in the US. So before 1981, you can see that the red line more or less track the ups and downs of this actual inflation. The green line on the other side, it's our optimal committed policy. You can see before 1981, it is lines below the actual inflation. But if you look after 1981, the whole thing reversed. So now the red line, the optimal opportunistic policy, appears to lie above the actual inflation, but the optimal committed policy implied by our model matches the actual inflation quite well. Just to be clear, this model implied policy, we did not use any information from the actual inflation to compute. So this is sort of a validity of our model's explanation power. I will talk about the lower part of this graph when we comes to later in the presentation. So I hope this graph catch your attention and convince you it's worth to stay for the next 50 minutes.
Yeah, and can I ask more of like a motivation question? I mean, we'll see the model, what commitment looks like in the model. I'm just curious what you think. There's these regimes that is it going to be like the ability to commit to future actions that we typically think about commitment? I guess what I'm
That's
getting
right,
at
exactly.
is how you think, yeah. How you
nailed it.
What,
so we think about commitment is you do what you say. You promise to do something, you deliver that. That's our definition for commitment. Yeah. All right, so now let's talk about some core model elements. So this is a pretty simple model. So we have a policymaker, and there are two possible types: committed type, choose and commits to a contingent policy plan. So it is settled when he first took office, and he's going to implement that afterwards. There's also the opportunist type who cannot commit. So he chooses his intended policy period by period. So to distinguish these two policy actions, we use A to denote committed policy, alpha to denote the opportunist policy. And the actual inflation is a random outcome based on this policy intention. So you assume an additive implementation error to this policy intention to generate the actual inflation outcome. So this is actually a noisy signal about the underlying intended policy. So the policymaker has a standard quadratic objective in inflation and output. The inflation is denoted by pi, output gap denoted by x. So we're going to have an inflation target, and we're going to have an output target. So we're going to assume the output target is positive. So the central bank has inflation bias. And we're going to give slightly different inflation bias to these two different types. But these are not very important to our result. More importantly, our commit type is patient with the discount factor beta. And in this particular paper, we assume our opportunist type is myopic. But our method, if I have time, I will talk about our method can be extended to talk about patient opportunistic type. So now let's talk about the private sector. So the private sector do not observe the policymaker's type or their policy intention, but they can observe the realized inflation outcome and then try to learn which type of policymaker they're facing by looking at the inflation outcome and compare that with the committed policy plan. Okay. And we also assume random regime switch in the sense that each period, the policymaker could be replaced, and that event happens with probability Q. If there is a replacement, everybody is going to see that. They see a new policymaker come in, but they don't know whether the new policymaker is a commit type or the opportunist type. So the private sector is going to interact with each other, and that's going to generate this new Keynesian Phillips curve, where this is the forward-looking expectation part, and we're going to have the inflation linked with the output gap, and we also have this cost push shock, which shifts the relation between the inflation and output around. So crucially, what the committed ability, what the commitment capacity can achieve is if you have a cost push shock, right? if you can change expectation, you can use expectation to offset some of the impact of this cost push shock and reduce the effect on inflation and output. And you're actually spreading the effect of the period T cost push shock over to the future period. That is the benefit of commitment in our model. So the timing in each period start with whether the policymaker is replaced or not, and that is observed by everybody. And then the cost push shock is realized, also observed by everybody. And then based on the cost push shock, the private sector is going to form expectation about next period inflation. And then the policymaker is going to take actions. So if it is a committed policymaker, he is going to implement the contingent policy plan he has announced at the beginning of his term. If it is the opportunist type, he just do what's optimal for him this period. Okay? But this policy intention is not observed. What observed is a random inflation outcome based on this hidden intention. And finally, with our inflation outcome, with our expectation, with our cost push shock, the output is determined. By the way, please feel free to ask your questions if there is anything unclear. So that's it.
Can I ask a clarifying question? Here, so when you say that the action is hidden, but only the inflation is realized, I wonder if the policy rate is something that people also observe and could be a way for policymakers to signal their type.
Yeah, right. That's a very good question. So in our current version, we didn't have a mapping from the output on inflation to the interest rate, but it can be done. So you can think about interest rate is a policy action, but whether interest rate leads to a high or low inflation is going to subject to some uncontrollable shocks by the central bank, right? So for example, now the Federal Reserve Bank is trying to control the inflation by, policy hike, but doesn't mean when they, increase the policy rate by 75 basis points, the inflation is going to come down. They said the reason why we increase policy rate is to bring inflation down, but whether inflation actually going to come down is sort of has some component beyond the control by the central bank. And that is the way we capture the reality. They do something, people see they try, but then the output, the outcome may not be exactly what they declared. And then people is going to compare the outcome with what they state they're going to achieve. And people are going to say, oh, how much they're going to attribute this deviation to some bad luck, or how much they're going to attribute this deviation by the central bank are not really telling us their true intentions. Maybe they should increase the policy rate by 1.5%, but they said, half of that is enough. But, so this is really about this learning.
Thank you.
Sure. So some highlight of our model component. So it may appear to be a standard regime switch model with private sector learning, but we have some important departure from this standard model. First departure is we have our committed policymaker being purposeful. So the committed policy is actually optimal from the standpoint of the committed policymaker. So we choose this modeling choice because we want to model this idea that the policymaker, especially central bank, are strategically use its policy plan to manage expectation. Okay. Second, we also have our policymaker that cannot commit doing the optimizing period by period choice. We wanted to use this to show that actually there are, although they cannot commit, but they actually follow this standard theory that they are responding to the expectation. And later I will show that this is very crucial for our model's ability to match the US inflation experience. And then we have this imperfect public monitoring, meaning that the policymakers set their policy intention and then the observed outcome maybe is a random outcome from this intention. So even if the outcome deviates from the plan, it doesn't necessarily mean the type is fully revealed. So we choose that because we want, this will allow us to have a richer reputation dynamics. So now the reputation not only can go down or can go up, which typically happens with this model, it can also go down, okay? And moreover, this reputation dynamics is going to generate this endogenous reputation depreciation if the outcome deviates from plan. So it's sort of like endogenous punishment from a deviation of the plan. If the deviation is large, then the reputation depreciates more, then the central bank suffer more from that deviation. And lastly, we also have this forward-looking expectation. This is deviating from our paper on JMCB more than 10 years ago, because we think the forward-looking expectation captures the idea that the central bank manage expectation to smooth the shock that are taking place currently to the future. And with that can only be done with forward-looking expectation, and it cannot be really done if you have a static expectation. All right, so now let's talk about the equilibrium of this model. So first, the private sector's belief. So let's define a history in our model that comprise of the past random inflation outcome, the cost per shock. This is what the public observe, the private sector observe. And then based on this public history, the private sector is going to form a belief on how likely the current policymaker is the committed type. So we call this belief rho, and this is the reputation of the policymaker in our model. And this belief is going to be updated according to the Bayes rule. So what if there is a regime change? Okay, so all our timing is related to a regime. So once a regime change in time t, we reset the regime clock back to 0. So it's the first period when the new policymaker takes office. And we're going to give this new policymaker an initial reputation rho 0, which is a random draw from a bounded distribution. And then the new public history is going to be this initial reputation, and then the first period cost per shock. In our calibration, we do allow some partial reputation inheritance for this new policymaker. So his initial reputation could be dependent on his predecessor's reputation. You can think about when Volcker leaves office, he has established this very good reputation as inflation fighter, and Greenspan was benefit from this good reputation made by Volcker. And then with this belief about which type of policymaker is in place, the private sector can also form inflation expectations, and that has to be rational. So there's two types of inflation expectations. One is a nowcast, right? So if there is a regime change in period t, then the nowcast of inflation will be a weighted average between the committed policy and the opportunistic policy, the weight being the initial reputation. But more generally, what about the expectation, the forward-looking expectation, the expectation about next period? So very similar, it's going to be a weighted average between next period policy if the committed type is in charge, and the next period inflation if the opportunistic policy is in charge. So it's going to be future committed policy and future opportunistic policy. The reason I don't put A or alpha is because it also has to take into account the future prospective regime change, but that's extra detail. And then this is optimization for the opportunistic type. Okay, so in this particular paper, we only look at the myopic opportunistic type. So he's only going to maximize his momentary objective, which is going to depend on inflation. That is a random outcome based on his choice of policy intention. Okay, so this is the weighted average and subject to this new Keynesian Phillips curve. And this allows to solve the policy rule of this opportunistic type. It's a linear best response to the expectation. So essentially, when the expectation is lower, then it's optimal for the opportunistic type to choose a lower policy. Okay, so in some sense, our opportunistic type has inflation bias, but that inflation bias is endogenous. Okay. So later you will see this is very important theoretically and quantitatively to our model. Lastly, let's talk about the.
Yeah, just a quick clarification. So then the opportunistic policymaker would like the reputation to be skewed as much as possible towards the committed type, or no?
Yeah, so here he cares about reputation in a very indirect way. So good reputation, later you will see, is going to bring down E. So if expectation is low because people's trust is going to be a committed type in place, inflation is well anchored, they're going to have low expectation. When the expectation is low, it doesn't need to have a high inflation in order to achieve his optimal output target. That's the intuition. So now talk about committed type. So committed type that are very different from the opportunist type, he is going to choose his entire contingent plan at the time when he took office, so at the start of his term. So it's going to be contingent plan because it's going to depend on the realized public history. And his objective is to maximize the present discounted value of his objective. So it's intertemporal objective. And when he's maximizing that, he realized when he chooses his contingent action, contingent policy plan, that committed policy plan will have strategic power in shaping how the private sector is going to map the public history to their expectation. Okay? So now let me elaborate what is this strategic power. So there are 3 channels for these committed policy to exert power on the expectation. First, it can manage expectation directly. Okay, so he can say, I promise you, tomorrow I'm going to implement a tough anti-inflation plan, so you should lower down your expectation. So they promise a future A. Okay, and also it can manage the perceived alternative, that, oh, maybe you don't trust me completely, I'm going to do that. Maybe you think I'm the opportunistic type. So I'm going to tell you that, well, if even if it's opportunistic type, he is going to not want a super high inflation as well. Why? Because your expectation is low. Okay, so he can manage the perceived alternative policy by influencing this expectation, because private sector knows the opportunist type respond to their expectation. If they have low expectation, the perceived alternative policy will also not be too bad. Lastly, the committed policymaker can affect the weight people assign to the future committed policy and the future alternative policy, right? This weight is a reputation. So how he can affect reputation, he can try to differentiate himself from the opportunistic type by having their policy difference very big. So people learn from the past, from last period, oh, very unlikely I'm facing a opportunist type. So even if opportunist type doing something terrible, I'm not too worried. Okay, so that is the reputation building channel. So the central bank that can commit will utilize all these 3 channels all together. And most importantly, these channels are intertemporally connected, right? So if you promise tomorrow you have a low committed policy, and you have to think about how this low committed policy is going to affect next period reputation, so on and so forth. So it sounds complicated, but we have a method to deal with that. Okay? So what we propose to solve this equilibrium in this dynamic model is to borrow the approach from mechanism design. Okay, so we're gonna think the committed type as the principal, and the private sector and the opportunist type will be the agent. Okay, and then we are going to so the thinking process is we're going to have the committed type choose his own path of committed actions over the course of his term, but he also going to choose for the opportunist types policy, but subject to this incentive compatibility constraint, that is this linear best response we just derived earlier. He's also going to dictate what the private sectors expect inflation will be, but this dictator respects the rational expectation constraint. Okay? So it's a principle setting entire state contingent plan subject to the incentive compatibility constraint for one agent, satisfy rational expectation constraint for the other agent. So why this is good? Because then we can use all this recursive method from this mechanism design literature. We can write this optimization for the committed type as a recursive form. So it's a generalization of Bellman equation by introducing this so-called pseudo state. This is the shadow price on keeping your promise as a committed type. Okay? So I'm not going to go through the details, but we will have this momentary objective. We'll also have this constraint that is capturing the rational expectation and the commitment constraint. So we also have the evolution of this pseudo state variable that capturing the shadow value of keeping the promise and the reputation. And we also have this Bayesian learning governing the reputation evolution. So this allows us to solve for the within region equilibrium. So as long as someone is in charge, there's no replacement, then we can use this recursive formulation to solve for the public perfect Bayesian equilibrium. And this also allows us to identify 3-state variable, okay? And which is the cost push shock, the reputation, and then the pseudo state. Okay? So based on that, we're going to have the optimal committed policy, optimal opportunist policy, and the equilibrium private sector expectations. But when we're doing this, we're going to take as given what people expect this future regime's inflation. So this is very standard when you have a model with stochastic replacement. Okay, so then we also impose a marker perfect across regime. So when you calculate within region equilibrium, you take the new region's expected inflation as given, but the new region's expected inflation has to be also rational that are using the optimal equilibrium decision rules. So there are one key trade-off.
So
Sure.
I'm confused about what you mean by regime. You mean when a new policymaker takes over, that's a new regime, or
That's
there are
right.
different?
Exactly.
Oh, I see. Thank you.
Yeah. So new regime means there are no replacement. So the same policymaker continues, but it could be doesn't necessarily means you have a opposite regime. It doesn't have to alternate. So you can have a committed policy regime, and you have a new policymaker, but the new policy continue to be a committed policy regime. But the key thing is the private sector do not know. So they're going to learn whether they're facing a committed policymaker or not by looking at the inflation output, inflation outcome, and how much that deviated from the announced contingent committed policy plan.
And in the Ramsey problem you solved in a few slides ago, that's within the same regime. Is that?
Yeah, that's within the same regime. That's why we have this discount. So this is the property that regime stays. So Q is a property that a new policymaker going to come in and change regime. So here we assume that if you're a committed policymaker, or then you only care about the payoff when you're in charge. You don't really care when the new policymaker comes in and what's happening during his new term. Okay.
Okay.
Right.
Yeah.
Okay, very good. Okay, so if we impose this rational expectation constraint that we assume that, you know, in the future, the committed policy and opportunist policy and this new regime expectation is going to follow this recursive fashion, then it helps us to obtain an operational expectation function, meaning that now this committee type can actually choose the expectation by only choosing these two variables, delta and mu prime. What is delta? Delta is the policy difference across these two regimes. So what's the difference between the committee policy and the opportunity policy? So obviously, this policy difference will determine the reputation. A larger difference is going to make people learn faster that they are facing one of the type, okay? And that helps to build reputation. Or it can choose this mu prime. So that's going to enter the future policy, okay? So this is the direct management of expectation channel. So in the paper, we show that actually when central bank is trying to manage expectation, there's a trade-off between these two channels, building reputation vis-a-vis management of expectation. So why I'm talking about this? Because imposing this operational expectation function help us to further reduce our recursive optimization. So instead of having to choose 4 different choice variables, now we only need to choose 2 choice variables, the policy difference and the future pseudo-state variable. Okay, so once you choose this, it helps you to pin down expectation, and that expectation is going to give you the optimal opportunistic policy and optimal committed policy. Then you're done. So it makes computation much more efficient than before. Okay, so I hope I convince you that we can compute this equilibrium very efficiently. Now let's bring our model to data. So remember, one important feature of our model is our opportunistic policy is responding to expectation in this linear fashion. Okay? So this plot captures how this inflation bias, which is the optimal opportunistic policy from this targeted inflation pi star, and how does that inflation bias responding to this expectation. Okay? And you can see that when expectation increases, the inflation bias also increases. And we define 2 boundaries. Okay? So the lower bound, we call that intrinsic inflation bias. So this is where the inflation expectation is most desirable. People just expect the inflation equal to the inflation target. Okay? So that is intrinsic inflation. And the upper bound is this Nash equilibrium inflation bias. So when the private sector fully expect the inflation going to equal to the optimistic policy, okay? And that could be big, okay? So when the inflation are moving up and down, and our endogenous inflation bias is moving up and down, okay? So you can see if we use the SPF as a proxy for the inflation expectations, you can see how our simple model do in terms of generating this very variable policy changes over time. Okay? So you can see that with our calibration, we're able to match the beginning of the 1970 inflation and all the way to the peak of the great inflation, just with this difference in the 2 inflation bias. So this is one part. And this is like
for this beta, for the discount factor, this does it matter? This is the discount factor of the public or the discount factor of the policymaker, or because I'm wondering, the policymaker probably has maybe what if the policymaker is more impatient?
That's right. Okay.
So maybe it doesn't matter if it's the private sector's beta that matters.
Yeah, this is the private sector's beta because I forgot to mention, we actually denote the policymakers beta by beta 1. So everything here is about the private sector's beta. So
now can I ask just a bit more about the theory? So also in the title you mentioned both commitment and reputation. So does that mean there may be a policymaker in principle that cares who are patient, and so he cares about reputation, but he's has limited commitment problem, or commitment and reputation are referring to the same thing? Like like for example, the Ramsey, like the social planners problem that you solve, is it subject to some timing consistency problem, or it's entirely time consistent? So there's no.
Okay, right,
yeah.
right, fair question. So our committed policymaker is going, it's not this perfectly mimicking a committed policy. So he is able to commit, okay, even if it may not be optimal ex post. He make a promise, he's gonna deliver that, even if there is ex post cost to that. This is our committed type. Our opportunistic type is capturing this thing, like he can do whatever he wants, ex post optimally. And in our particular paper, we assume that opportunistic type is myopic. He doesn't care about the future, but he has a way to respond to inflation expectations, right? So in some sense, reputation also matters for him in the following sense that higher reputation reduce expectation. So he doesn't need to have a too big inflation bias to achieve the same output level. Yeah, so we're trying to separate this concept by using definition of different type. So I guess
it's important for you. So it's important for you to have both like commitment and reputation in a model to match the size facts. I mean the inflation dynamics and bias.
Yes, we need to at least this is something in private sector's head. They think there is going to be a type who is going to stick to the plan they announce, and they're also a type that do whatever they think optimal ex post, and they don't know which type they're facing. So this learning is very important. And our learning is going to interact with this optimal policy in both regimes. That's what helps us to match the facts. Yeah, so maybe I think it will be clearer if we look at what exactly we're matching. So for the sake of time, I'm gonna skip the detail of the calibration. The paper has the details. So how are we gonna link the theory to the data? So we have 3 state variables. All of them are latent to us, right? And but in our model, we have a mapping from the state variable to the optimal policy in both regimes. We also can map this state variable to private sector's inflation forecast at arbitrary horizon, right? So what we do is we underutilize this part. We say, okay, let's try to match the SPF inflation forecast with our model inflation forecast. And that allows us to identify these state variables period by period. So each period, we find what is the state variable that help us to generate model implied inflation forecasts that exactly match the SPF 1 quarter ahead and 3 quarter ahead forecast. So this is our matching moment. We match the forecast data. And then we're going to use this extracted state to calculate the optimal policy. And then we use this optimal policy to compare with the actual inflation data to see how good our fit is. Okay, so we only take the expectation data and we compute our model implied inflation data and compare that with actual inflation. So why we're matching the 2 horizons of SPF? Because we think, borrowing the term structure interpretation from the interest rate, we think there is a spread, but actually we don't say, we plot the spread of the difference between the 1 quarter ahead forecast and 3 quarter ahead forecast. And you can see from this spread that the near term inflation forecast is going to reflect a more temporary cost per shock. Okay? It's highlighted by this red circle. You can see that we know in the mid-70s there's this energy shock, and here you can see this is where the premium is pretty high, around 2%. So we utilize this fact to extract the reputation and the cost per shock from matching these two inflation forecast series. And we check how well we do with untargeted inflation forecast. So this highlight on the right panel, you can see even if we don't target them, our model implied forecast matches with the data pretty well. And now let's compare our optimal inflation with the actual inflation. Okay, so the red line again is our optimal optimistic policy. Okay, so and you can see this is the one that tracks the US inflation pretty well. How can I say that? So basically we take the difference between the actual inflation with our model implied optimal policy, and we plot it in the lower part. Okay, so these are the ones that are fluctuating. And we try to look at the pattern. And to us, there seems to be a structure break around 9081, right? So like the green line, up, slowly follow down, all the way down. And similar with red line. Okay, so we're like, maybe there's something going on with here. And then we try to use this as a breakpoint. We say, okay, let's compute the mean of this deviation. Okay, and we find that before 9081, the mean deviation of our opportunist policy from the actual inflation is around 0. But the mean deviation of the committed policy from the inflation is quite positive. So our interpretation is this inflation in the United States is generated by an opportunistic policymaker. So this is an opportunistic regime. Okay.
And can I
sure.
I'd like to remind you that you have 13 minutes left, but I also want to distract you with a few questions.
Sure.
So first, can I ask you, did you, in estimating this, did you impose that there is a single breakpoint?
No,
because
no.
It could have been 2, 3, anything?
No, we didn't impose anything. So what we did, we just compute the committed policy, and we compute the opportunist policy, and we try to look at where they start to do better in matching the inflation. And we find, oh, there is a breakpoint in around 9081. And by looking, and then we do it more seriously. We say, oh, let's compute this mean. And we find, well, actually the green line did much better after 9081. The red line did much better before 9081. Bob, you want to say something?
And then I want to questions. One is, when are there regime changes? And the vertical lines show what our assumptions are. We say, as a starting point, let's assume there's a regime change every time there's a new Fed chairman. Okay, so that resets the multiplier mu equal to 0. Then we can create our series. After that, we look at the results and we try to decide which part is commitment and which part is not.
And then my second question is, what is the data limitation that doesn't let you go beyond 2005? Obviously, we all want to know what's going on right now.
Yeah, so we don't really have a problem. We just want to be very cautious because we think after 2005, the zero lower bound it could be a very important constraint to the economy. And that was not present pre-2005. So we would like to have a different model for that. Although I do have results that show you our model fit for the whole sample is not too bad. I actually do have it here. But we don't want to brag about that. So you can see this is, we compute all the way to the most recent one. And this is the model. So this is the average deviation of committed policy from the actual inflation. And again, it seems 9081 continues to be the breakpoint. But
yeah, I'm happy to see that.
Is 2020.
That's the breakpoint. And the other question, I guess, is why can't you extend it before 1970? Does the survey not exist?
Oh, yeah, because SPF doesn't allow us to do that. Yeah, okay. Sorry.
Can I ask a question about the Phillips curve? So I'm not very familiar with the literature, but I thought there's some debate about the slope of the Phillips curve, and does the slope matter for your result and how?
Yeah, so here we actually take a stand. Our Phillips curve is quite flat. Let me find here. Yeah, our slope of Phillips curve is, oh, sorry. Yeah, so this is our slope of Phillips curve. It's very flat. So yeah, we think that this is pretty consistent with the current consensus of the literature. There's a new paper by Nakamura Stanson that tried to estimate the slope, and this is quite consistent with their estimates. Okay. All right, so I have 10 minutes. Let me be a bit selective. So we're going to use this 9081 as a breakpoint. So now I'm showing virtually the same figure, but we're now put the solid one as the policy in place, and then there is a shadow policy that is what in people's head. Okay, so why this is important? Because we plot it together with this SPF, which is in blue line, and you can see that this policy in place before 981 lies above the expected inflation. So that explains why there are persistent positive forecast error before 1981, and why the switch to persistent negative forecast error after 1980, because now the policy in place lies below the actual the expected inflation. And we also show you that there is a so the bright blue line is the extracted reputation series, and you can see the scale is plotted on the right side, and you can see there is a very big movement of the reputation. Okay, and the extracted cost push shock is plotted in the color magenta, and you can see compared to the reputation, the volatility is much lower. And in this graph, we try to show you this reputation dynamics is very important for us to generate this good match of our policy to the US inflation. How we show that? So we plot again our model implied policy, but in the dashed line, we try to shut down the reputation dynamics. Okay, so we're going to set the reputation equal to the sample mean average around 0.6. and stay there. And the other two state variable, we just keep the same. And you can see that, so our model implied policy matches the post-1981 inflation pretty well, but if you shut down the reputation dynamics, you can see the constant reputation policy lies above the actual inflation policy. So if we don't have reputation dynamics, we cannot, our committed policy cannot match the great moderation. So if we go to our optimistic policy, we see our optimistic policy did pretty well before 1981, but that's because we have reputation dynamics. If we shut down reputation dynamics, this is dash line, we're going to miss the great inflation by a lot. Okay? So this shows you it's very important that our reputation is going to move around. And the lower panel shows you the reputation dynamics together with this key choice variable, which is the policy difference. And you can see there's a strong co-movement between the reputation and the policy difference. And more importantly, you can see where our reputation dynamic matters most is where the policy difference deviates a lot from its constant reputation version. So we try to explore why it is the case. We try to see how our reputation affect the decision rule. Okay, so I'm gonna skip this red line. Forget about the red line. Just look at the blue line. It shows you that our model allows us to have a higher. So this delta is going to be negative. So larger delta. Sorry, let me say that. So basically, if you have higher reputation, it means the policy difference is very small. So in our model, higher reputation is going to generate slow learning. And the fast learning only occurred when you have low reputation. And this is the one that enables us to match the US inflation pretty well. And while I have the red line here, the red line is showing you if we don't have the opportunist type being maximizing, okay, then we cannot generate this slow learning at high reputation. And that's going to, this is not very desirable, okay? So I think the last, I have 4 minutes. Okay. Let me just show one interesting thing, which could be quite relevant to the current situation. So this is a simulation of our model. I shut down all the cost per shock, so I shut down all the cost per shock and the implementation error, except I put a cost per shock in the middle. Okay. So first, we assume that the central bank start with a good initial reputation. And you can see this is a simulation where the inflation equal to the opportunistic policy. So it's interesting to see this learning is very slow. So it resembles something like in the early 70s, why people don't learn immediately. They're facing the opportunistic type. It's because we have this interaction between opportunistic policy and expectation. When you start with high reputation, expectation is low, then the opportunistic policy is also low. So it's very hard to tell whether you're facing the committed type or the opportunist type. And then the slow learning lasting quite a while until the economy is hit by a 1% cost per shock. So the cost per shock actually helps to review more likely that you're facing the opportunist type. So that's where everything starts to deteriorate very fast. Expecting inflation start to pick up, and because expecting inflation pick up, the optimistic policy also pick up. The policy difference from the committed policy plan is become larger. People learn faster, and you rapidly deteriorate into this Nash equilibrium optimistic policy regime. So we think this sort of saying something that could be happening now, right? We used to have a very sluggish expecting inflation until this supply chain shock hits, and then people see that the inflation does not respond too well, and now the inflation expectation starts to pick up. Then it's very hard to contain the inflation expectation. So this is why our model is relevant to the current situation. And lastly, I want to show 2 pictures, counterfactual pictures. So what if we just assume that there's a committed policymaker along the whole time, okay? And we're going to give the committed policymaker the same cost per shock and to see what happens, okay? So this is a green line. And you can see it completely misses the great inflation. It's going to respond to somewhat this energy shock, but that's not going to lead to a great inflation. And then you may ask, what if we just assume away learning again, but have this optimistic policymaker in place all the time? Then this is a red line, okay? And you can see this is too high relative to the actual inflation, okay? So some people use the red line to say, oh, the 1970s great inflation cannot be explained by optimum policy with lack of commitment. We say, well, that's because you don't incorporate that the optimal policy without commitment can respond to the expectation. Once you introduce this in action, you know, this policy without commitment can pretty much explain the great inflation very well. All right, so lastly,
sorry, just very to be clear, this is the effect of like the opportunistic policymaker sort of now concerned of losing the reputation.
No, here there's no reputation. Here I just assume this is full information. The private sector know they are facing a opportunistic type, and the opportunistic type is doing this, following this Nash equilibrium thing.
I see. Do you have the example where you can compute? So say you start reputation at everyone knows it's opportunistic, and you know the 1970s versus they have this constraint where they worry about losing reputation.
Actually, we are working on that because currently our optimistic policymakers are myopic. he doesn't
Right,
really
so
worry too much about losing reputation, but our
right, you
model,
need some,
yeah. So I need a forward-looking opportunity type. Yes.
thanks.
So the last, our model can also generate these credibility series, because people say, what is reputation, right? And people talk about imperfect credibility all the time. So we're also able to generating the credibility measures. So one measure is the credibility gap, which is what people think the actual inflation will be compared with the announced policy, right? And there's another measurement called degree of probability, which is how likely the inflation is going to fall into a neighborhood of announced plan, right? And interestingly, this credibility measure co-move with our reputation very well. So you can think about all these credibility measure constructed by the literature can be suggestive to a measure of reputation in our model. So this could be tested. All right, so let me summarize. So in this paper, we propose a model that features regime switch, optimal inflation policy, and private agent learning. Okay, so we think we are among a very few papers that can match jointly the expected inflation time series and the actual inflation time series simultaneously with quite parsimonian model. And we also propose a method that can solve a dynamic game with expectation linkage across period using a mechanism design approach. So we can solve this equilibrium in a recursive way, which is very convenient. And we also propose a way to extract latent state variables suggested by the recursive method that allow us to connect our model implied time series to the data. And looking forward, we're working on constructing these interest rate implications by our output and inflation target. And we're going to work on this inflation forecast. And lastly, as Zach pointed out, it's also quite interesting to explore what if the opportunity type is a longer horizon rather than a myopic type. But currently with a myopic type, we already match this period of US inflation pretty well. So we're going to stick with that in this current paper. But of course, extending that with long horizon opportunity type will be a future path of research. Thank you very much.
Thank you so much, Yang. You've been amazing, finishing in exactly 1 hour. So I didn't have to reveal my type if I'm an opportunistic or strict moderator. We will be starting the next talk sharp at 10:45 Eastern time. But now we have time for discussion. Anybody else got questions for Yang or Bob?
I have a perhaps not so serious question. So when we see the Fed announces that it's going to target, instead of the inflation rates directly, they're going to target the average inflation rate. What does that reveal about the Federal Reserve's type?
Right. Okay, so it's very curious because we had presented this paper, I think around 1 year ago, more than 1 year ago. At that time, I believe we already have this supply chain shock. And then people were saying, don't worry, the inflation expectation is sticky. Let's keep the interest rate low and let's react when we see a move of this inflation expectation. Okay. And then we were trying to argue that this is a wrong approach because it's going to hurt the reputation of the central bank as being serious to deal with inflation. And we will see a pickup of inflation expectation if there's no action seen to deal with this supply shock. And then after a few months, I think the reality is unfolding in the way it's consistent with our suggestion. And we also have a companion paper that are looking at exactly this average inflation targeting. We actually find some private sector report which said this change of policy framework is very vague. They don't know how long they will allow the inflation to be up and how high above average it will go. And that's create a lot of ambiguity in what the central bank gonna do. And we also see this takes a bite now in our inflation expectations. Bob, you want to add something?
I actually was going to turn to a question raised by Professor Zhang about interest rates, which is a really good question. In general, in optimal policy models, once you've solved out for inflation and output, you have the complete stochastic process. So if you think everything in the world is going to depend on the state variables. If nominal interest rates are a function, depend on expected inflation, plus a real interest rate that depends in some way on expectations about the future, then we can calculate nominal interest rates and real interest rates in our model. And one of the things we're working on now is sort of making sure we've got the code right on that and starting on comparisons. But what that also suggests is that if a committed central bank was choosing to implement those interest rates, they convey no additional information about the state variables above and beyond, or type above and beyond the things in our model. At least that's my current understanding. It's an important topic in terms of making connections with actual central bank practice.
Yeah, I was wondering, like, related to your discussion. So, like, when we see on FOMC meeting days, there's a surprise to, like, there's a shock to people's expectation about future policy rates. Maybe that shock is related to people's update about the central bank's belief, central bank's type. So then you can use those FOMC announcements shocks to policy rate to maybe, anyway, to calibrate your model or something.
That could be particularly important for going back before we have the SPF.
Can I ask you
also true about that earlier period is that the Fed was not very forthcoming with the details of its interest rate policies. So we're going to have to think carefully about how to best do that.
Thank you.
Can I ask you to maybe lean outside the window a little bit on make a daring forecast of what's going to happen next? Because Yang, if you could show us a slide again where you're extending the data up to the present, I suppose, so that's not the slide where you're also graphing the reputation, I think.
Oh,
but
yeah.
Their reputation the reputation can't be looking very good right now.
No, So
I'm just wondering if you can simulate that forward with an opportunistic or a committed policymaker, and well, how are they going to get out of this pickle?
Right. So you can see
I think one critical thing is whether or not we perceive that August 2020 was really a regime change. I mean, the Fed said they were moving to a new 5-year plan for managing inflation, and that they were going to move away from some standard things like preemptive policy, et cetera. Maybe there's a new regime at that point, and the characteristics of it are perhaps unknown to individuals, in which case I think it could be problematic moving forward.
I think it was a little bit, my question, what I was thinking of at least was more akin to 1973, where which I think you're interpreting as saying that the policymaker might have been opportunistic to begin with, but had a good reputation, so people didn't know this, right. And it took the cost push shock to reveal that the policymaker wasn't as committed as people were maybe giving them credit for. And so the question is not, was there a regime change in August 2020, but were Powell and maybe even Yellen already opportunistic policymakers and we just didn't know?
If you look at how close the red line and the green line are between 2000 and 2020, I think you would conclude that the people in our model don't really know. It's pretty close. It's pretty hard to tell. And so reputation won't move very much. And so maybe we're getting some information.
Right. And I also want to add like how we probably think about this summer 2020 regime, like the policy frame change, because we adopt a model where our inflation target is a constant equal to 1.5%. I think at that time, if you seriously believe they're going to have this average inflation targeting, I think there's tremendous confusion about what is this time varying inflation targeting. Is this going to be state contingent? If so, what state? And even if you know what state, you don't even know the mapping. Is this like 5% too high or 8% too high, right? So I guess you would need a different type specification, but still you can use this learning about, you could have a type that have a permanently higher inflation target, because that is some policy discussion. And you can also have, some like a specific path of really like having the inflation target up for a state contingent period. And then you can learn which type it is, right? But then, so that's why, we don't really think this constant inflation target model is suitable to look at the inflation post 2020. You can see like how much this inflation actually shoot up after 2020, right? It's really comparable to this energy shock period. And our model, we have a shoot up of optimal policy, but it's not really comparable with this actual inflation shoot up. So I think it suggests there indeed a change of inflation target going on here. So let me just make the last comment on an earlier question Shenshin raised. So how does this, like, how can we think about this, something like a sustainable plan style research, right? So basically, in our GMCB paper, so we have this within period expectation. So we do have this distinction between short-term credibility and long-term credibility. Long-term credibility is more or less about the type, whether you're facing commit type or non-commit type. Short-term credibility is really about how likely the non-commit type is going to mimic the commit type. So even though they may have a low reputation, but the policy announcement is pretty credible because this is sort of like sustainable. So if you have a sustainable plan, then it's very credible, even though people know for sure he is the type that cannot commit. So this will happen if we can discuss more on that once we have a patient optimistic type. So we have this mimicking thing going on, active mimicking.
So I'd like to close just with a couple of comments. Yang's slides disappeared, but one of the things that we did is we Googled the words monetary policy, credibility, reputation, targets, etc. And there are a huge number of hits for monetary policy, of course, but when you combine it with ideas of reputation and credibility, there 20% or so of the discussions of monetary policy contain each one of those concepts. Then we Googled monetary policy plus estimated credibility and estimated reputation, and we found 100 or so versions for estimated credibility, and many of those were about exchange rate regimes, and we found 2 for estimated reputation. So while the central bank community talks a lot about reputation and credibility, the quantification is really pretty limited. And so what we think of our paper as doing is providing an illustration of the fact that this might be important quantitatively for US inflation history. And we hope that other people will join us in investigating whether this is true or not, and develop further and better models in this area.
Thank you so much, Bob. PhD students in the audience, but also really everybody take note. No time to lose. Michael Weber is going to present on the subjective inflation expectations next.
Thank you for all the questions, comments.
Okay, so thanks a lot, Lucas, for having our paper on the program. For everyone in the audience, greeting from Barcelona. So, like, given that this article Lucas asked us to present is kind of an overview article that we wrote for the Journal of Economic Perspectives, what I want to do now is actually, like, handpick a couple of results that we discussed in this article, and then discuss a little bit more about 2 of the underlying papers in a bit more details. Like, I think shouldn't come as a big surprise. Like, policymakers obviously care a lot about inflation expectations. That's a quote from Jerome Powell from last year, and actually specifically was referring to inflation expectations of households in this quote. And then you could argue, well, why should we care about households, not about financial markets or professional forecasters? Like, if we just write down a simple subjective version of a Fisher equation, let's say we all face the same policy rate, but for whichever reason, that's actually what I want to focus on the next 60 minutes. We differ in our inflation expectations. This then maps into heterogeneity in perceived real interest rates, which of course then, through consumer Euler equation could affect our consumption savings decisions. I will talk a little bit about that later on. There's evidence that it matters whether we do take on leverage, which type of mortgages we take. But also actually might matter for stock market participation. And of course, right now, a big discussion is whether, do people that expect high inflation go out actually, like, bargaining for higher wages? And is there potentially a concern of a price wage spiral? And also, like, for the effectiveness of monetary policy, we might think that actually the understanding of ordinary Americans about inflation could be quite important. Conventional monetary policy narrative is like, we have well-anchored inflation expectations. So therefore, whenever policy shifts around rates, this maps into movements in real interest rates, and then those mechanisms here could be operative. But you could also say that actually, especially in times when we are potentially stuck at an effective lower bound and we cannot move around policy rates to stimulate the economy, we might actually still be successful in getting aggregate demand up if we somehow were able, through communication, let's say, to move up expected inflation by households, and then actually still somewhat engineer a negative perceived real interest rate. Now, what I first actually want to do is, like, maybe this cushy policy narrative of well-anchored expectations is maybe something we should pretty much, at least when it comes to households, somewhat actually forget. So this is like from a survey we did in 2018, where we asked 25,000 Americans, after explaining to them what inflation is and what an inflation target is, what do you think is the average inflation rate the Federal Reserve, that is responsible for monetary policy in the US, tries to achieve over longer periods of time? You do see, let's say, a little bit less than 20% of people could have, like, maybe some reasonable knowledge of what an inflation target is and what the Fed tries to do. You also see in here, we just bunch all the answers. It's about 40% of survey respondents, 25,000 Americans, representative for the overall population, that actually thought the inflation target is a number larger than 10. Now, this, of course, doesn't mean that, people or the central bank couldn't potentially kind of shift and manage the expectations of ordinary Americans. I'll come back to this point later on in one of the papers I want to talk about in more detail, to the extent actually the central bank could somewhat pierce the veil of ignorance on the side of households. Actually, they adjust their expectations quite dramatically, but crucially also actually, they then actually adjust their consumption decisions in line with their inflation expectations. But it's just, unconditional differences, lots of dispersion in the data. But there's also some more systematic differences, and this is just coming from here, a figure we had just used the New York Fed survey of consumer expectations, average expected inflation between 2013 and 2018, just simply collapsed the data by gender. Period when average realized inflation was below 2%. So you do see, without any data treatment, just download the micro data from the New York Fed survey with consumer expectations, point estimates for 1 year ahead expected inflation. Everyone has a substantial upward bias, but the upward bias is actually way larger on average for women than for men. And this actually stylized pattern that has been first noticed in an AER paper in, I think, 82 by Jonung for Swedish households, and has been confirmed actually, across countries, surveys, and time periods. Is something very pervasive that, for whichever reason, it looks like women have higher inflation expectations than men. And we started working on inflation expectation with Francesco da Punto in 2014. The first time I presented internally a paper on inflation expectations in Chicago, Anil Kashyap went viral and said, I don't think anyone should work on inflation expectations until they can explain to me why women have higher inflation expectations than men. And, as a junior faculty back then, you try to somehow impress, I guess, your seniors. And so it's kidding to some extent, but what we then did in kind of a survey where we were actually able to elicit, the evidence so far is all across households, female versus man. Here we were able to contact the male and female household head within the same survey. Here, no panel, just a single cross-section. So what you see here, this is the average difference in 1 year ahead expected inflation rates between female and male household heads. So here you see even within household, where lots of things we were able to keep constant, like, household income, number of kids, housing choice, mortgages, and so on. You do see on average for households in the US that the female household head has about a 0.4 percentage point higher expected inflation rate relative to men. Then what we did, we had a survey question, who within your household is in charge of grocery shopping? I always do it, I never do it, and once in a while I do it. If you just simply then here in the right panel split households into, I guess, what we call in the paper traditional households, where the male household head declares to never participate in grocery shopping for the household, you see this unconditional difference increases by, 40–45% to about 0.7 percentage points within traditional households. Instead, it totally vanishes within households where the male household head also goes grocery shopping, at least to some extent. And the reason for that is because the average husband in this panel also has higher inflation expectations. So to some extent, it looks like being exposed to the volatile price changes when grocery shopping somehow leads to higher expected inflation. And so this pattern that what you perceive and the signals you see kind of in your daily lives, that this kind of matters for your overall 1 year ahead expected inflation rates is actually very pervasive, actually replicated this here in this JP paper with Olli, Yuri, and Francesco da Punto, also from other surveys. You just simply now look at a bin scatter plot, and those that actually think that right now, over the last 12 months, inflation was very high, also have very high 1 year ahead inflation expectations, vice versa. If you perceive low inflation, you also expect low inflation going forward. So somehow it looks like, how we look and perceive and kind of feel inflation really matters quite a bit for what we think will happen to inflation going forward. And then actually, this is, I'll come back to this later on. So if you just ask people directly, and this is actually from a survey on 50,000 Americans, who just said, well, in randomized order, here are different sources of information that might be relevant for you when you think about inflation. can you please tell us the top 3 sources that you actually would use when you actually think about inflation? Most important, we actually assigned a score of 3. Second most important, a score of 1. Least important among the top 3, a score of 1. And then just simply actually look, and you see by far the most important, according to people in the survey, is that, well, our own shopping experiences are really kind of the information signals we would use when forming overall inflation expectations. Instead, like, TV or radio or newspaper, substantially less important. Social media to some extent, but certainly, like, it looks like, at least in this sample, own shopping experiences really kind of the key source when forming inflation expectations. And not just to directly show you, and I'll come back to this, how we do that later on, why this actually then directly matters for inflation expectations. So here we were actually then able, given that we ran this survey on the Nielsen home scan panel. So home scan panel, you can think of it like, it's like 60,000 households who have an optical scanner at home, and whenever they purchase any good that has a barcode, so predominantly like, grocery items, pharmaceutical items, small durables, they would scan that at home. And then, like, at the daily frequency, what people purchase in like their more or less non-durable bundle, the prices they paid, did they use coupons, was it on sales, where did they purchase it? And this is a panel starting in 2014. So effectively what we then can do, we can just do what the BLS is doing, create a chain-less pair price index with 2 subtle differences. Instead of looking at an average consumption bundle, we have a household-specific bundle. And instead of using like, average price changes, we have price changes that an individual household witnesses over a 12-month period. And if you do that, then you see that the households that over the last 12 months had the lowest realized inflation rate in their own shopping bundle have about a 0.5 percentage point lower 1 year ahead overall US inflation rate relative to households that actually had the highest realized inflation in their consumption bundle. So it looks like, it's really important what you actually notice in your own bundle. And then this is something, if we have time, actually I'll show you in more detail at the very end. What we also show, actually households do not, like, the BLS would do, weigh price changes by expenditure shares in a base period. Instead it appears, or at least that's what the data really seems to kind of scream at you, people actually weigh goods based on how frequently they purchase. So if you create like what we call like a frequency CPI, it's really like, this weighting by frequency that seems to actually drive this cross-sectional variation in 1 year ahead expected inflation rate based on realized inflation rather than weighting by expenditure shares. And actually, this is also like what people tell you in surveys, like, if you tell them like, are there specific goods that come to your mind when you form overall inflation expectations? And here, this was just, an open text field. We didn't actually say that what they should answer, which of course also meant like processing this data was kind of a mess because of typos and kind of different ways of writing. But what we kind of see is actually the fact that, people, mention really things that actually they kind of purchase frequently, like milk, the price at the pump is important, bread, eggs, coffee to some extent. This was then for the 6th most mentioned was the price of beer. There are also some gender differences. Men were more likely.
I assume you've also asked, like, are these the goods that you buy? I mean, I'm assuming they're looking at these because these are the things that they representatively buy.
So here, actually, we didn't ask them that, but you indeed see that. So like in some other work with the Cleveland Fed, what we've been doing is like, at the PCE category, we asked them for like expenditure shares, but then also for a kind of importance for them for inflation. And there's actually a strong correlation between like expenditure shares and also like kind of how important they think it is. But I actually come back, Lucas, that's a great point. I think the next slide exactly to, I think to some extent a little to shed a bit more light also on what you just asked. So like, the only thing I wanted to say, I think also like there's some anecdotal evidence, there's actually also cross-country differences. and what those important goods are. Like, in France, for example, there's a survey that suggests that actually the price of baguette is really important. You might have figured it out based on my accent. I'm from Germany. I would guess that if we were to do this survey in Germany, the price of beer would be way more important. There's certainly differences in the goods that people think are relevant for inflation.
Yeah, and when I'm teaching macroeconomics, my real numeraire good is always coffee.
No, I can. Maybe actually then too many of our survey participants took your class, and that's maybe why they answer this way. So yeah, the reason why I think actually this is kind of important. So if you think back about the summer of last year, lots of discussion about the price of rental cars, or now the price of flights. If you think, the policymakers oftentimes said, we don't worry too much about that. It's like, an initial inflationary impulse or relative price increase in narrow categories. It's not broad-based. If those price increases do happen in categories that are very salient to consumers, you might actually have that inflation expectations spike up quite, for overall inflation quite immediately. And I talk about this later on also a little bit. You tend to see that households actually put a larger weight on price increases relative to equal size cuts. So even if magically the Fed was able to now actually lower inflation on the spot, I would still expect actually that inflation expectation would somewhat stay elevated, because it looks like actually people don't actually adjust downward their inflation expectations as actually they adjusted upwards to equal size price changes. And so this is actually now a bit more directly related to Lucas's question. So like in January of this year, we actually recontacted like the same households in this Nielsen panel. And what we did is we, given that, so in this panel, we do observe the goods they purchase, we do observe the prices they pay, but also the prices they paid in the past. And then we also just elicited their overall inflation expectations. And what you see here, if you actually calculate based on what people tell you, the price of milk they typically purchase in the typical quantity and at the typical kind of outlet, and ask them also what the price 12 months ago was, and you just simply, do a bin scatter plot against the overall general CPI inflation rate, you see that it looks like indeed there's a pretty strong correlation from like what people thought happened to the milk price over the last 12 months to overall inflation expectations. Now, I also mentioned that we can observe actually the actual price they paid, both in January, but also a year earlier. What you actually see is that people have a pretty good kind of, knowledge of current milk prices. However, they do systematically underestimate what the price of milk was 12 months ago. Now, if you think about it, this figure from earlier, that we do see this generic upward bias for most households. If I have downward biased memory of past prices for individual goods, and actually to some extent, I, inform my inflation expectations for overall inflation based on the perceived price changes for these goods, this potentially, at least in part, can help us understand where this upward bias in inflation expectations can come from. And, also maybe more anecdotal evidence. Some of you might have followed this discussion in the European Monetary Union. So like, for example, in Germany, when the euro as a paper currency was introduced, like perceived inflation by Germans was in the order of 8–9%. Actual inflation was below 2%. And so people just, even now, if you ask them, my parents mention this pretty frequently, they thought that restaurant prices kind of doubled. So they just changed the euro for Deutschmark when the numbers stayed identically. And that's why they thought actually that inflation is so high, but actually realized inflation was pretty tamed during that period. And so it looks like indeed that somewhat, people thinking that goods were cheaper in the past than they actually were.
But sorry, since you brought this up, Michael, did this only happen in Germany? I mean, in Greece, the prices were also redenominated in euros, and I'm sure businesses would have just as much loved to take advantage of the confusion as in Germany.
It's like I'm less familiar with like the evidence in Greece. I'm more familiar with the evidence in Italy. because actually there was
all right, sorry, never mind Greece. They even joined later, right?
Yeah, no,
Italy,
totally. But
France,
so like, you know,
Spain.
for France, for example, there's actually even like an edited book, I think by Francesco Lippi, if I remember that correctly. They actually had a couple of articles exactly documenting that. And so like for one paper, they went to like the movie theaters and asked people just coming out of the movies what the price of a movie ticket was in lira in the past for a year ago. And if we looked at what they said and compared to, you know, to average prices, at least in Italy, like the number they gave for the price in lira was last time was 93 or 94, if I remember that correctly. So like they also systematically underestimated what the price of going to the movies was in Italy. It's more anecdotal evidence, but at least seems to be consistent with that.
So
like,
Michael,
yes.
so I have a related question. So, then this seems, so in psychology they have this anchoring effect, right? So if you just they just gonna say a number that is, you just have a random thing and then you just say a number. So there's one concern that then, you know, this number may not be very stable, right? You just ask them another thing like maybe the TV, and then they're gonna report a much lower number because, you know, the TV doesn't have their price increase so much. So first of all, this is like the stability about the inflation expectation survey reported. And the second is this underestimate this past price pace. Is this related to like their general inflation experience? Or like, for example, if you ask the same question to the Japanese household, right? Do they overestimate their price paid in the past because they have the deflation for a while?
Yeah, so Yang, great questions. Like in terms of like anchorings, like the way we elicit perceived inflation here is like at the current price or the price change, so the current price minus price 12 months ago, exactly like to alleviate the concern of anchoring. Because like if it was an anchor, if I would ask them, you know, what do you think was the percent price change of milk? And then I say, I don't know, 20%. And I ask you, like, what do you think is overall US inflation? I again say 20%. I think, you know, then I would be really concerned about anchoring. I think just asking about like price now and price 12 months ago helps to some extent. And also like, you know, here we have to, maybe I should have been clearer here. Like if you look at the numbers on the axis, like, you know, there's not a slope of 1, it's way flatter than 1. All I'm saying is that those that actually perceived high price, past milk price changes are also the ones that expects high future overall inflation. And in this like memory and beliefs papers with Francesco, like what we actually do is a little bit like at the beginning queuing exercise where randomly half of the sample, we tell them to think about whether there's a gas station on their way to work to create what is cognitive psychology literature calls like interference. And you do see like the ones that you kind of interfere and kind of almost prime to think about gas prices. For them, actually, this kind of association is not in the data, which I guess, you know, helps us a little bit to also get closer to causality, which I think, you know, helps a little bit against this anchoring. Now, in terms of like inflation experiences potentially determining the way this up or downward bias goes, I think actually that's a super interesting question. Unfortunately, you know, I haven't seen any work on that for other countries, but would certainly be curious to see that. But I'm definitely sympathetic and could see that happening. Okay, and so like, you know, just to come back a little bit then to also like what was mentioned earlier, where it's like, you know, to which extent, you know, how can we to some extent understand part of this heterogeneity inflation expectations? And also like, you know, we do see in the data that some policies are very effective. Other policies that operate through expectations, at least for households, are not very effective, and people don't seem to react to it. Like, you know, in the US, there have been many studies documenting, for example, that people leave thousands of dollars on the kind of table by not refinancing when actually interest rates go down. And so like here, kind of what we did is like, you know, for example, think about what's by now this famous forward guidance puzzle. By now, there have been like, I think 4 or 5 different theory papers that kind of all model kind of agents with some form of limited cognition, either being it finite planning horizons a la Woodford, being it like level case thinking a la Fahey-Werning, or kind of like a behavioral New Keynesian agent, like a BEX, like, it's all different type of micro foundations, but they all kind of imply that the agent in the model does not actually form a kind of optimal decisions, because like has some form of limited cognition. To get an idea actually whether this to some extent could be actually what's going on in the data, we actually went to Finland. And the reason why we did that is because for men in Finland, you can go to the military and observe from like the military entrance type test what their IQ is. Then you have an identifier to which you can link like survey data. What do you think is inflation over the next 12 months? And we also actually have like, tax data. So we have like income, we have some form of debt balances, assets, car registry data, all of that type of stuff. And so here simply what we kind of did to kind of get an idea whether this form of, non-optimizing agent type of theory could potentially be partially helpful in understanding heterogeneity that we do see in the data. We actually just simply, look what people think by buckets of IQ. So this is what, the military calls a Stanine distribution, a standardized 9 distribution. So like, the lowest 4% by, the highest 4% by in this IQ test consisting of, I think, 160 questions in a given cohort receives a 9. Within a given cohort, the lowest 4% of answers receives a score of 1. And then most of the mass is somewhere between 4, 5, and 6. What you see here, if you like just simply look at what people think happens, and this is data from 2000 till 2015 to inflation over the next 12 months, subtract what is exposed is realized, then you take the absolute value and you collapse it bin by bin, you see actually a quite sizable mean absolute forecast error for the bottom 4% of a man in Finland. It's monotonically decreasing, but still quite sizable at 2%. And, this association holds in the data if you condition on income, on education. So it really seems like, more innate cognitive abilities seem to be quite important for how agents form expectations, but also then how well they're at forecasting. And we also show like, anyone who's kind of at 5 or above, almost behaves like our textbook agent in the sense that, if this man in Finland expects high inflation, he is more likely to go out and consume more, versus down here, you do see, pretty kind of, bad expectations. But even within those that have exposed somewhat reasonable expectations, but have low IQ, there's zero association between their consumption and inflation expectations. And we can also directly rule out that this is due to any form of financial constraint. So it really looks like, there's kind of, what we in some follow-up we call a human friction to like how people actually react to policy.
Michael, but I have to say a 4% mean absolute forecast error is almost cute compared to the, people saying that the Fed's target might be 10% or 20%. So these people are they're too educated for being the 4% of Finnish men who have the lowest IQ. The only way that makes any sense to me is if, as part of their military training, they've also gotten, occasional civics workshops, and maybe they at least they have a little bit more knowledge about inflation than, let's say, the average grocery shopper.
Yeah, no, so that's a great point. So like, we have a little bit of discussion in the paper also, like why we do think, for example, that Finland is actually kind of a nice laboratory for disentangling more cognitive abilities. So like, I think I'm more comfortable interpreting like the heterogeneity across high and low IQ rather than the level, because like Finland is a country like, it's rather racially homogeneous. Education is virtually for free, even college education. And I think that helps us to some extent understand level differences, but there's still substantial differences in the cross-section by at least this proxy of IQ from the military. And so here we actually use data from Germany just to exactly make this point that policy complexity could be quite important to understand, like, how people react to it. So like some of you might recall that former Chancellor Merkel in Germany was elected in 2005, so a long time ago. And when she was elected, like, Germany was, I guess, similar to now, in dire straits. We were breaking the debt to GDP Maastricht criteria 3 or 4 years in a row. There was a pending infringement procedure by the European Union. And then what Merkel announced in November of 2005 that she wants to increase value-added taxes, so like a form of consumption taxes or sales taxes, from 16 to 19%, but only effective after 14 months in January of 2007. Yes, in January of 2007. And some of you actually might be familiar with this theory paper in the AEI by Correra, Nicolini, Teles, and Fahy, where they actually make the point that you can use consumption taxes to kind of imitate what monetary policy would want to do when they are constrained by an effective lower bound. Effectively, what they are saying, if you want to engineer a negative real interest rates in a fixed nominal interest rate environment, you can just actually increase or pre-announce an increasing path of consumption taxes. Through that, you can actually then mechanically increase inflation, and then you should actually get that people start go out and shopping more. I know my interpretation of of their model. And if you actually look at that in survey data, this is the German version of the European Commission Consumer Confidence Survey, so similar to the Michigan survey of consumers. And here, like, this is just the share of Germans that expect higher inflation over the next 12 months relative to the previous 12 months. Like, it monotonically starts increasing, then it's kind of almost the highest right before the increase. Then actually VAT goes up from 16 to 19%, and inflation expectations come down again. If we then look at the fraction of Germans in the survey state, now it's really a good time to go out and purchase larger ticket items. It also monotonically starts increasing right before the increase in consumption taxes, and then starts coming down again. So this is just the motivational figure of this paper. We also show that more carefully in regressions and actually like in a matching different diff estimator. But I think this just pure raw data evidence kind of tells it identically. Instead, now if you would compare it to like the first two explicit forward guidance announcements by Mario Draghi in July of 2013, when he said like, current policy rates will stay at current or lower level for an extended period of time. And it also explicitly said like, this is the first time we explicitly use forward guidance as a policy tool. And then he firmly reiterated that in January of 2014. You don't see anything happening for inflation expectations, nor really for durable purchases, neither on the spot nor delayed. So, if you now think through at least the mechanism in the new Keynesian model, like, promises to keep interest rates low until the end of until after the end of the liquidity trap, this should be inflationary in the future. My dad should understand, this will be creating inflation. So therefore today, adjust his inflation expectations upward and should go out buying a new car, let's say. Just doesn't seem to happen, at least through the lens of this survey in Germany during the time period. So it looks like, at least from a theoretical perspective, both policies work exactly identical through the consumer oil equation, but you indeed see that, complex policies don't really seem to work. Instead, like, a simple policy that just tells you like pretty much hardwired what will happen to inflation is pretty effective in moving expectations and at least consumption plans. Some of you might have heard that the Merkel also did exactly the opposite experiment, so to speak, in June of 2020, where she announced that on the spot, temporarily, she will lower consumption taxes from 19 to 16%, going back up in January of 2021. And actually we did the opposite exercise, and you see exactly the same. It just works beautifully. Like, people indeed, like, the simple policy seem to be pretty effective in getting people out to buy stuff. And there we also have scanner data from Germans, and you also see that in realized scanner purchases. Okay, so like now we saw that, there's lots of dispersion, some biases and all of that. So like, does this mean like, we should forget potentially about consumer expectations? They're anyways all over the place. Like, I personally think the answer is no. And the reason for that, I want to show you now in the next couple of slides. And this is also like, I think kind of shows you that what we see in surveys is also still relevant for households' actions, and we just have to understand like how we can reach those households and how central bankers potentially could manage their expectations. So like there's some work with Olli and Yuri that we did in 2018. And so like the way we wanted to understand whether communication can potentially manage expectations of households, like this Nielsen panel, I'll tell you a bit more in a few slides, like take those in this survey, 25,000 Americans, elicit some of their demographics, and then just, ask them, what do you think will happen to inflation over the next 12 months? That's what we call prior inflation expectations. The way we did it here is similar to the New York Fed survey with consumer expectations, like this Mansky type format. You have pre-specified bins ranging from +12 to -12 with certain ranges, and then you ask them to allocate probability mass that has to add up to 100 before they can continue. Then the key part of the survey was then like the information provision part, so like where we just simply split our sample into 9 different groups, 1 information groups that received information and 1 control group that didn't receive any information. We also had a placebo treatment that got some information that we thought shouldn't be relevant for the inflation expectations, just to actually disentangle spurious learning or anchoring effects from like genuine learning. And then like those treatments were randomly assigned. Subsequently, we then elicit again posterior inflation expectations. Now, of course, you can imagine if we would ask the exact same question twice, people would think like, am I taking a test? Are those guys trying to fool me? So like the posterior, we elicited via a point estimate, just to actually not really ask exactly the same wording twice. Okay, so what are the treatments? Like, at that point, realized CPI inflation was 2.3%. We told 1/9 of the survey that the inflation target is 2%. We told another treatment from a group that the forecast by the Federal Open Market Committee was 1.9%. One treatment group had to read the actual FOMC statement, pretty dense, long text, contained all of those 3 summary statistics. We forced them to stay on the screens, like to increase the probability that people actually read it. Then to see like whether the print media can be just be a better substitute for actually trying to directly communicate with households. We chose a coverage in the USA Today about the most recent FOMC statement. The reason why we chose the USA Today was because like it's a nonpartisan paper that hadn't actually kind of traditionally I don't know how you say, like endorsed presidential candidates. To see whether people had a Phillips curve in mind, we told them what the current unemployment numbers was to see whether people kind of extrapolate from salient price changes to overall inflation. We told them that gas prices rose quite a bit over the last 3 months. And then our placebo treatment was the true fact that over the previous 2 years, in June of 2018, the US population had grown by 2%. We chose that horizon because like, we want to have a number that's kind of close to the numbers that many of the treatment groups actually also received. Okay, and so then what did we do econometrically? So like we have posterior expectations right after the survey. We actually recontacted everyone after 3 months and after 6 months to study also the persistence. And then we have the prior expectations. And we just simply look at the forecast, the updating at the individual level for 1 year ahead inflation expectations. It's not really material for us that we actually had different elicitation methods, given that we have a control group that had the same wording. To the extent the wording leads to systematic differences, this control group sucks up this systematic difference. We regressed on treatment dummies, 0 for the control group, 1 to 9, 1 to 8 for the individual treatment groups. We also have observables, shouldn't really matter, given that we have randomized treatments, but it's like age squared, income, marital status, number of kids, college education, stuff like that. And so what do we see? Shouldn't be a surprise, ex ante, pretty much everyone was upward biased in their inflation expectations. Then you tell them like what population growth was. You do see some mild form of anchoring. It's about 1/10 of the cross-sectional standard deviation of prior expectations. So like, no, it's not super sizable, but all the treatment coefficients down here, you might actually kind of subtract like the 0.2 percentage points just to actually kind of get rid of this potentially spurious learning. Then you see, like, if you just look at simple summary statistics, they're actually quite powerful in lowering 1 year ahead expected inflation, going down between 1 and 1.3 percentage points. Like, just informing people the Fed thinks that this is what will happen over the next 12 months. If you actually force people to read the FOMC statement, which of course contains way more information, conditionality and stuff like that, but at the same time actually uses Fed speak and is way more dense, you do see that the effect is pretty much in the same order ballpark as the simple summary statistics. Instead, actually, if you give people like the USA coverage to read, the effect is only half as big. And I'll come back to that in a second. Instead, like, ex ante, people actually had unemployment perceptions that were higher than what we told them. Instead, actually, once we tell them that it's like, pretty low, they actually lower their inflation expectations. So, this is pretty common in household survey in the US. People seem to have like, a supply side view of inflation. They always associate high unemployment with high inflation and vice versa. Remember, we just said like, ex ante, inflation expectations were already really high. You tell them that gas prices actually rose a lot in the last 3 months, and they update upwards their inflation expectations by even more. Now, we dug a little bit deeper to understand where this difference here in treatment comes from. Like, clearly, like, the complexity cannot be the reason. And so, like, we asked people also, like, to which extent do you trust the different sources as a source of information about monetary policy and macroeconomics, like print media, social media, family and friends, and so on. And print media just consistently ranked lowest. And then we actually thought, like, is it because USA Today maybe has a bad reputation among our survey participants? We asked them to rank different newspapers: New York Times, Washington Post, Wall Street Journal, Chicago Tribune, LA Times. And what we find, and of course USA Today, actually within those, or at least those with broad-based coverage, USA Today had the highest credibility. Slightly higher was only the credibility of Chicago Tribune and LA Times, but also a large share of survey participants said, I don't really know how to rank them because I'm not familiar with them. So, like, among the broadly familiar newspapers, USA Today had actually the highest degree of trust. So it just looks like there's a generic distrust towards like the media when it comes to informing yourself about monetary policy, at least in this survey. And then, now we have posterior inflation expectations with random treatments. What we now can do, we can now use those treatments to instrument posterior expectations to engineer exogenous variation. And then, remember, we have like after 3 months and after 6 months, we contacted the same households. And in those surveys, we also like asked them over the last 3 months, how much did you spend on 10 different categories, which we then could add up to actually look at their spending over the last 3 months, but also over the last 6 months. But the nice feature of those households is we can actually also look at their purchases in the Nielsen panel with the scanner data. I think like the first thing, and I should have brought the figure here, what we actually show is that actually literally almost to like $10 or so on average, like what people state in the survey dollar-wise, how much they spend, lines up literally almost perfectly to what actually we see in the scanner data, to what they spend over the last 3 months. So at least those panelists we contact seem to be actually really good in actually recalling what they spend, and it lines up with the actual spending. Nevertheless, what I want to now do is actually now just show you, is it now the case that people that have exogenously higher inflation expectations do actually spend more subsequent to our survey experiment? And so what do you see? Like, if you request log spending on their posterior expectations that are instrumented.
I'm sorry, Michael, I didn't understand how the
Yes.
spending is measured here. Is this like an intent to spend, or is this like proportion of your income that you're not saving?
So this is like where it's like so two ways we do that. So like when we say total spending in the survey, after 3 months of the initial survey, we ask them over the last 3 months, how much did you spend in dollars? And then like, you know, on, let's say, on pharmaceutical items, on education, on, and the more specific examples on like groceries and so on. And then we just add it up. And we do the same after 6 months. So this is now what people reported in terms of dollar spending over the 3-month period after the survey and the follow-up survey. And down here in panel B, this is like in the 3 months between like initial survey and follow-up survey, how much they spent in terms of dollars in the Nielsen home scan panel, like with the actual home scanners at home. So this is down here, actual spending. This is ex post reported spending.
Something to understand why you think this treatment give you exogenous posterior inflation expectation.
Like, you know, if you would just use the posteriors, like, you know, they are still a function potentially of others. It's like, but the treatments, they are we randomly provide them, and then people adjust their posterior. So we want to have like the systematic component of like the posterior expectations induced by those treatments. You know, we provide, you know, if you think about a Bayesian framework, like your posterior should be a function of your priors and the signal we give them. And the weight on the signal should be a function of the Kalman gain. And we now actually want to isolate the part of the posteriors that is actually induced by our treatment.
But then, so you get this posterior after they have made their purchase, right?
No, this is like before they made their purchase.
Oh, before
they
made their purchase.
Yeah. So posterior, I mean, it's in the survey wave in June of 2018. We have like prior expectations, randomized information provision, and then posterior expectations right afterwards in the same survey.
Oh, in the same survey. Okay, I see.
In the same survey.
Got it, got it.
Okay, perfect. Thank you. Okay, and here you actually see like, you know, pretty strong instruments. Like here we don't have to be concerned with weak F sets or weak instruments. So the T sets are pretty sizable. You actually see like somewhat persistent effect, at least in the home scan data, that's less prone to measurement error. Like in terms of point estimates, like even in the survey, it's still positive and economically similar magnitudes, but you know, then after 6 months, there's just too much noise. Okay, so like now briefly, like here we see that like, you know, to some extent it looks like the, you know, the medium via which you try to reach consumers could be important to the extent they react to information. I just briefly want to show you 2 plots where I think from other papers also like the message you send is important and the messenger who sends kind of this identical message might be important. So this is some work again on Finnish households where we do the same type of setup. You know, we elicit priors within the same survey. We randomize different pieces of information that we provide to them in the survey, and then we elicit posteriors again. And so what we wanted to do in the survey is kind of go a little bit after this kind of, you know, target versus instrument communication that Angeletos and Chen Lian have been arguing. It could be, and Sastry, pardon, is actually potentially relevant. And so like what we meant here is like, the lab, what we do is like we want to keep constant the sender of the message, which in this case was Olli Rehn, the governor of the Bank of Finland. We wanted to keep constant the medium messages from his official Twitter account. And then we wanted to use, this was a survey in June of 2020, like, you know, policy responses that resemble either like, you know, an instrument, like, you know, specifically, what did now the central bank do to potentially alleviate, you know, the hardship of the corona pandemic versus what was the aim of the policy intervention. And specifically, like what we used is like the instrument communication that we showed, like a screenshot of the tweet by Olli Rehn was simply saying, well, we now just passed the pandemic emergency, I think PPE purchasing program of, and a really big number of several, I don't even know, I guess in the US it would be trillions, it was billions of euros. Anyway, so like big number, I forgot even now the exact number, versus like the target communication simply stated, don't you worry, we'll do whatever it takes so that no Finn has to suffer from the corona pandemic. And then you just simply, and it's just, this was the easiest way to graphically show that. We ask them subsequently, to which extent do you think this policy will actually benefit Finnish households? 7, it will benefit a lot. 1, it won't benefit at all. And what you should see is here, like for target communication, this whole histogram was shifted to the right. So it looks like on average, people across the whole distribution thought, the simple announcement, don't you worry, actually is way more comforting. And we also see that people have subsequently higher personal income growth expectations relative to receiving like the specific instrument that they actually implemented to achieve this target. So here it looks like, the type of message central banks send matter to which extent actually households might actually react to it. And so here there's some work with Andreas Fuster, where we want to understand like whether at least for a different subpopulation, it kind of matters who is sending the message. Like the setup here is again like this kind of survey information provision experiment or survey RCT, if you like this expression better. So like, what we did here, we elicited kind of prior expectations for inflation, the unemployment rate, and then we just randomly split survey participants into 3 different groups. 3 groups saw Mary Daly, 3 groups saw Raphael Bostic, 3 groups saw Thomas Barkin. And at that point, all 3 non-voting alternate members on the FOMC, we specified their title, all Fed presidents, regional Fed presidents, and we showed a picture of them. And they all saw identical numbers. We said, well, here's the forecast from the summary of economic projections of June of 2021. And, Mary Daly or Bostic or Barkin, depending on who you saw in those Friedman screens, they were part of the meeting and contributed their forecast to those numbers you see here. Then we elicited again posterior expectations. So we do the same exercise, posteriors and priors, depending on how, who you saw. But again, I think graphically it kind of worked easier in doing it now this way. We also elicited, to which extent do you trust that the Fed is in charge of setting basic levels of interest rates in the US, actually is able to manage inflation and the unemployment rate, or cares about the well-being of all Americans? Like, it didn't really matter in which way we elicited trust. Ex ante, you saw lots of dispersion in average levels of trust. And that's what we try to do, is to see, like, is there heterogeneity in the extent to which people have low trust? That was a, share of trust being a 1, 2, 3 on a 7-point Likert scale. And you tend to see, like, ex ante, you saw that women have lower level of trust or higher level of distrust. And then, when they see Thomas Barkin, a white male policymaker, their level of distrust was 46%, decreased to like 41 or 42% when white women, so Bostic and Daly. Certainly among white men, there was very little dispersion. And actually the effect was even kind of stronger for black male survey participants. Like, here you see, like, if black male survey participants sees Thomas, Raphael Bostic, black male policymaker, or Mary Daly, white female policymaker, sorry, you see like the share of distrust decreased by 8 or 9 percentage points. And for black female survey respondents, like, they become more distrustful or more trustful, less distrustful when they see Bostic and Daly relative to Barkins. Like, we should also show it matters for like what they expect for unemployment and inflation. So like it seems to that women and black survey participants, at least, are more willing, we show that also, to gather information about monetary policy when it's actually a kind of communicated by a black or female policymaker relative to a male policymaker, at least in that survey. Okay, so now let me actually come back to like some more stylized figures, and I feel actually I won't be able to talk way more in detail about another specific paper I wanted to mention, but like, you know, this is now again from this JAP paper of ours. You know, oftentimes you say, hear people like, oh, you know, I don't care too much about 1 year ahead inflation expectation. At the end of the day, like what really matters for the effectiveness of monetary policy is that long run inflation expectations are well anchored, you know, to the extent that, you know, indeed people have well anchored expectations, maybe due to shocks, their short run expectations go up and down all the time. But, you know, they do understand the Fed will do whatever it takes. And then, you know, they will actually see, we will see that their long run expectations are actually well anchored. If we look at that in the data, doesn't seem to be actually the case. Like here, what we do, instead of just correlating 1 year and 5 year ahead inflation expectations of households, we actually look at what people do from 1 month to another. So like we look at forecast revision, so like almost taking out an individual fixed effect, and then see if people update upwards their 1 year ahead inflation expectations, what happens to their 5 year ahead forecast for inflation. And like if people had well anchored long run expectations, the line should be flat. Instead, you know, you see like there's a pretty strong correlation between forecast revisions for 5 year ahead inflation expectations and forecast revisions for 1 year ahead inflation expectations. Like when you update up what's your 1 year ahead expectations, you also think actually 5 years out inflation expectations will still actually be substantially different. And now I want to actually also briefly zoom in into what happened on the one hand to realized inflation early on in the pandemic and to like inflation perceptions and expectations during that same time window. So here we use just the underlying data from the Nielsen home scan panel and just simply create like a simple measure of realized inflation quarter to quarter. Now, of course, given that in this period there was lots of substitutions, like the way we create realized inflation, we use effective prices in a narrow kind of category. Instead of now looking at the exact same UPC, so type of milk, we focus on dairy products and then effective price changes. And we do allow for like substitution across kind of expenditures across categories, and that we actually look at an average bundle in this quarter and last quarter to measure realized inflation. And similar like to what Kaplan and Schulhofer-Wolf find, like or like David Argente and Lee, you know, in normal times, not much heterogeneity in kind of realized inflation across, let's say, the income distribution. What you, however, see is that, you know, in right at the onset of the pandemic, actually, like, and this is now quarter to quarter inflation, so like annualized, there's an opening up a gap in realized inflation in this home scan panel of about 4 percentage points. And it is to some extent, you know, I guess what Niyayamo and co-authors call like a trading down mechanism to some extent being operative. So like you're a rich household, you go to Whole Foods, never use coupons. Instead, like the pandemic hits, you want to save, you trade down to Trader Joe's, start using coupons. If you're at the bottom of the income distribution, this margin of adjustment is not operative. Similarly, you know, typically I only buy the kind of the branded good, then I go to the kind of store brands, you know, all this type of margins are just simply not operative for lower income households. And you see that actually there's an opening up of realized inflation early on in the pandemic. And similarly, you see that, you know, both the mean, but also like the dispersion across individuals actually spiked up quite dramatically already in like Q2 of 2020. So pretty early on, like expected inflation, the dispersion inflation went up, expected inflation went up quite dramatically. You didn't really see that in, let's say, what the New York Fed is plotting on their webpage or the Michigan Survey of Consumers. In the Michigan Survey, there you have this design issue. If you, a survey participant, answer a number larger than 5%, the interviewer, it's a phone interview, asks you back as probing you, you know, said a number larger than 5%. Are you really sure? And of course, like you might actually revise downwards subsequently. And the New York Fed, like, on the web page, what they do, they use the probability distribution implied mean. And there, remember, like upper bin means 12% or above. And then they use the median of this implied mean. So like by construction, you couldn't actually see anything early on. It's like, all I wanted to say here, realized inflation went up and immediately you see inflation expectations going up. I think actually I'm out of time. So like, only thing I want to mention is if we look at the limited evidence for firms, this is what Ollie and Yuri have been doing in this survey of firm inflation expectations, way more similar to households than to professional forecasters. So likely quite a bit of the things we know for households now. We don't really have good data for firms, unfortunately, at least for a long time series. I guess it's also relevant for firms. We've written a couple of overview papers on inflation expectations this year, I guess, because finally, after a decade of getting rejected, no one caring about inflation, people start being interested again. And so like, let me skip over that and then now effectively leave it here. So like, I think the key takeaways from some of the work we've been doing is that at least what I think is relevant is like, you don't really need a broad-based increase in inflation to see spikes in inflation expectations. I also think there's a concern that even if realized inflation goes up, we might still see a substantial period of elevated inflation expectations because like this larger rate of price increases relative to equal size price cuts. And it also seems that like the messaging of central banks is important in terms of like both the message, the medium, and the sender matters. We do see like if central banks are able to reach ordinary people, they do adjust their expectations towards the provided signal, but crucially also like they do adjust their consumption in line with the Euler equation. So like, there's hope, but at least the current conduct of policy communication, I think, given the large dispersion we see in the data, is not necessarily effective of reaching most Americans.
Thank you so much, Michael. More questions from everybody. Everybody is asking lots of questions. So I have a question then, Michael. Can you say a little bit more about how much the ordinary American matters here? Because, either sad or totally fine truth, depending on your leanings, is that, income is so dispersed, which would mean that I guess for, if you're talking just about aggregate demand, it's the richest, maybe two deciles that matter the most. Mm-hmm. When you're talking about, you can talk about wage setting, but then the household's expectations are filtered through unions or maybe other bargaining mechanisms, who presumably a union leader can have better information about inflation than the members, although of course they have an incentive to misrepresent their knowledge.
Yeah, no, totally. It's like, of course, like the wealthiest households, they have the highest share of income and whatever, but so like, it's also the case that you see that the lowest income households, they have the highest MPCs in the data. So like, they consume like, 100% of their disposable income. And like, to the extent, if you add them up, they're a sizable fraction of consumption. We I guess should care about them. You could even say like, given that they don't behave really like an optimizing agent, like it's even like a blessing in a recession because you can send them checks and then consume it all rather than kind of like smoothing intertemporally. Like for this Finnish data, it's actually a nice setting because like we can actually disentangle quite nicely kind of cognitive abilities from like income or education. And it's like in those papers, we always kind of separate like, 6, 7, 8, 9 versus 1 to 5. And if you look at the share of income in our sample of those people that don't behave in line with an Euler equation in this setting, their share is 49% of income in our sample. And they just don't optimize intertemporally. Like in that setting, 50% of the overall income in the sample is, I would say, quite sizable and should matter quite a lot. If I would think about maybe like, let's say maybe stock market investment portfolio choice, there would maybe
the fact that they don't optimize it to temporal, it means that they have high MPCs and you can send them checks, but then why do their expectations matter? So maybe their spending power matters, certainly for, stimulus checks, but, your talk is mostly about their expectations, and the expectations matter because of, Euler equations or various reasons. But, if the people with the worst expectations also don't really incorporate their expectations into their decisions, then their expectations don't matter.
No, totally. But so like, then if I was a policymaker, I might be really concerned by that finding, because like, in times of where central banks are also potentially prone to populist attacks, if I was a populist politician, I would figure that out. I would say like, this kind of institution conducts policy only for 50% of the population. And like somehow,
well, no, they're conducting it for everybody. They try to get inflation down low and stable for everybody. But I guess what I'm saying is that the main reason I think we're worried about expectations is because we're worried about persistence. We want the high inflation to come down again. The easiest way to get it down is to convince everybody that it will come down. And that's why we're worried about expectations. But the people who are hardest to convince are also the people who don't really react to their expectations, right? We need to convince the people who do respond to their expectations.
Yeah, no, totally. So like, let's maybe go back to September of kind of last year. If you look at actually like where the biggest kind of increase in wages was, it was actually the bottom of the income distribution. Only like later last year, you saw like, a more broad-based increase in nominal incomes. And like, you did, I think there's a big difference, for example, between like Germany and the US. Like, I think the reason why we saw way more wage pressure in the US is exactly because we don't have unions, and people, saw that labor markets are really tight. There's kind of help wanted everywhere, and people either actually kind of, bargain for higher wages at their current employer or just actually switch jobs. And you saw that quite dramatically. And it's exactly those people that have like the highest inflation expectations. Now, obviously, right now, I don't have a paper on that yet. We actually ran a survey, exactly pinned down this mechanism to see whether people with higher inflation expectations right now also have higher wage expectations, and whether they bargain, in fact, for higher wages and would adjust the labor supply. But at least like, the fact that we did see that wage increases were concentrated at the bottom of the income distribution, where you also have all else equal higher inflation expectations, typically would indicate that at least like in this specific episode, the people with their high expectations, given that they had higher relative bargaining power, did actually potentially act on them.
Thank you.
Thanks.
So I just have a question about take this message of your paper. Like, for example, you basically mentioned that this communication of forward guidance has very limited effect on people's expected inflation. So like, for example, are you based on what you're talking, maybe they should actually tell people the forward guidance is try to lift inflation expectations so that it's going to have a stimulus effect on the economy, and everybody should spend more, and that will actually lift inflation. So because there's two things. One is you communicate the target. Another thing is to communicate the mechanism, right? Because I felt this forward guidance has this two level of complications. One is, people don't know, like keeping inflation at zero, keep the interest rate at zero. What does it mean, right? Second is people, because I felt that forward guidance relative to the consumption taxes, it's more like sort of like a coordination, right? It works because it bets on people inflation expectation gonna rise, and that's how it works. But if people inflation doesn't rise, it's like self-fulfilling, like it's gonna fail, right? So this like level of coordination, which doesn't happen with consumption tax. So when you're trying to prescribe a way to make forward guidance more effective, which way you're thinking that should be done?
I can, I haven't done it, but there's some like related work from people in the Netherlands that I've seen, where they kind of like, explained, like, this is now this pandemic emergency purchasing program. That's the reason why, like, the ECB kind of passed it. That's like the intended transmission mechanism. And then they ask them, what do you think actually will happen, kind of. Like, if you tell people, at least in their survey, they kind of then reacted in line with what the policy aims to achieve. My personal kind of biggest concern with that setup is, like, it's a pure, what we would typically call demand effect. Like, you tell me how it operates, then you ask me whether I think, GDP will be higher, unemployment will come down. You just told me that a couple of minutes ago. And so, like, you do see it there. So, like, there I'm a little bit more skeptical whether indeed we can interpret that causally or whether that's potentially a survey demand effect. But I definitely think that, if you want to use, like, policies to be operative and effective through a household expectations channel or consumption savings mechanism, you do have to kind of explain in, I guess, what Angelotti would call, like, simple, intelligible words, in crisp, simple words, how it should work and why you should be affected. But I think, like, the verdict is still out in kind of, more causally documenting that, I would say.
But in general, you sort of feel like if the policymaker try to communicate to the public about a policy, it's better to communicate the target rather than instrument.
So at least for the target, it's such a potentially simple kind of way of saying, well, of course, like, what we do is really complicated, but, trust me, we'll do the right policy implementation so that nothing will happen in terms of, Finnish GDP, something along those lines. Now, of course, this requires a high level of trust, which, of course, you as a central banker have to earn, a high level of credibility, as we saw in your talk. And so, like, that's, of course, a necessary precondition.
Because the Fed has been very hesitant to have this explicit inflation targeting. Exactly, they said, okay, we don't want to tie our hands, so we just explain we're going to do this, and hopefully it's going to lead to that. And you probably are suggesting, people don't understand all this level of complication. They just understand you're unsure about the policy outcome, so they won't align their expectation with what you hope for to achieve, right?
Yeah, I think actually, like, maybe even in that setting, we have to think, like, more like, you look at professional forecasters, and I do think, like, there, for example, or if you look at financial markets, having an explicit target is useful because they understand it, and they react to kind of an explicit target. Instead, for households, I don't think that an explicit target makes any difference. They don't know what the target is, they don't even know what it means, and they're kind of a different type of communication, at least given the current level of knowledge about monetary policy, would be more powerful. Now, of course, we could say, well,
Michael, you've been talking about Finland, and I'm just wondering, do they have an explicit target? Are they better at communicating it?
So, like, Finland is part of the European Monetary Union, which now also has, like, an
explicit
target.
No, any Finns in the audience, I apologize.
It used to be like,
part of the,
yeah.
Well, are they better at communicating it?
So certainly, like, it seems to be like, the current governor. So he used to be like a politician before. He was a European commissioner before. Like, it's definitely way more known by the broader population, which, I think makes a difference. He's very active indeed on Twitter and has a reasonably big followership. So maybe, like, the fact that he kind of, was already previously known to people might help.
I suppose in the euro area over the last decade, there has been a lot of discussion of the ECB's inflation target. So maybe European people right now have usually in a controversial way, right? We're talking about, like, why aren't they doing this or that? How about the southern members and so on? But maybe there's more awareness than there would be in the US right now.
Yeah, I think, the issue also, like, in the euro area is that, they, until last year, they didn't have an explicit target. It was close to, but below 2%. And then, like, what does it really mean? If some, given that inflation has been persistently below 2%, then the former chief economist Ottmar Issing actually wrote this big article that fantastic, as a German, of course, he said, fantastic, like, having an average inflation rate of 1.4% or whatever is, fantastic achievement, because after all, we want to have a number below 2%. And, there was lots of debate and then what it really means. And yeah, I don't know whether I haven't seen actually numbers for Europeans' perception on that.
Okay, our next talk presented by Leonardo on the fiscal theory of trend inflation. Leonardo, where are you calling from? We're trying to collect as many time zones here as we can. I don't hear you right now. I still don't hear you.
Can you hear me?
Now we hear you.
Okay, great. Fantastic. Let me see if yeah.
So as we're saying good night to our China
Hey,
and Hong Kong audience.
Can you hear me?
Yes.
Yeah, so I'm in Chicago. I'm at the Fed.
Okay, good. That's then I think we're really covering almost everything because Zach will be on Eastern. All right, it's yours.
All right. Okay, let me share the screen here. Okay, first of all, let me thank the organizer for putting the paper to the nice program. This is joint work with Francesco Bianchi and Renato Faccini. The usual Fed and European Central Bank disclaimer applied. So this is a paper in which we try to introduce a new theory of trend inflation, onto a theory that can explain persistent movements in the inflation rate. And our angle here is to explain this persistent moving inflation from the fiscal, for the fiscal side, from using fiscal policy. And we apply this theory, and we show that this theory can, which we're going to highlight in a second, is useful to understand the high inflation in the 70s and the great disinflation period in the early 80s, and the persistent low inflation in the 90s and 2000 and in 2010s. And then we're going to use this theory to sort of like interpret the most recent period and try to figure it out, how persistent is the current bout of inflation that the policymakers are confronting with right now. And so what we do in this paper is really to take a Asian Keynesian model, off the shelf, and augment it with partially funded debt. So we assume that there are two part of the government debt. One is that it is considered to be funded, part of the government debt is considered to be fiscally unfunded, meaning that agents do not expect there will be a fiscal backing, that the government will be able or willing to raise primary surplus to fund the share of debt. So the interesting feature of this model is that, with respect to all other business cycle shock, monetary and fiscal policy, and all the changes that all the macroeconomic propagation, the propagation of business cycle shock is very similar to a standard Keynesian model. And this is a nice feature, because basically the model, with respect to the shock, the model is able to match the standard business cycle dynamics. For this, there's going to be also unfunded fiscal shock that is going to affect the share of fiscal and funded government debt. And for those shocks, you can see that there's going to be a movement in trend inflation, persistent moving inflation, because basically the central banks coordinate and let inflation to rise. And this configure a fiscal zero trend inflation, and that is going to be the center of my presentation. So the idea here is having a model that features basically all the ingredients that has been proved to be successful, displaying U.S. business cycle dynamics in this model. But we add these additional shocks that as another propagation, and I'm going to show you, it propagates to fiscal and macro variable in a very particular way. And in particular, what is most interestingly, it can generate a highly persistent change in inflation. So the model, as I said, features a standard set of shock, including a persistent shift to the Phillips curve that we interpret as non-policy factors that can affect inflation in the long run. Okay, so that this is going to be, to interpret this shock, you should think about the shock like a shock that move the long run inflation expectation and therefore move 50 New Phillips curve up and down. And so it's an empirical question whether the unfunded shock, the unfunded fiscal shock that we introduce help explain the data, in particular the dynamic of trend inflation.
So a quick,
yeah,
just very
please,
quick question. So the focus will be obviously on trend. I guess without the monetary authority responding, it could, if the fiscal shock unfunded could affect current inflation. But is that the idea that you're going to have the monetary authority kind of in this passive role, responding to whatever the fiscal authority is doing?
Yeah, there is a coordination with the fiscal and monetary authority. In other period we study, not these particular shocks, but if monetary authority, when I say accommodates, I mean that there is this shock that is interpreted to be fiscal, that's going to increase government debt, and this increasing government debt is considered to be unfunded. And an agent aspect that the central bank, the monetary authority, is okay with this increasing inflation. So the central bank is okay with the fiscal authority to use inflation to stabilize this share of government debt. If the central bank does not, that's interesting. I mean, in the sense that you generate, you need to change the model a little bit because you have it with the indeterminacy and. But you can tweak the model in a way to see that still you have a persistent effect in inflation, but you also have a much more pronounced effect, a negative effect on output, on consumption and output, because basically you enter in sort of like a vicious circle of raising rates in response to this inflation. By raising rate, the economy slows down, debt to GDP rate will go up. They generate further, inflationary pressures, and so it depends on how agent believes this increasing the debt to GDP ratio resulting from the contraction in monetary policy will be financed. You can get interesting dynamics, but today we are not looking at that. Today we look at the world of the perfect combination, perfect coordination, in which there is a sort of an implicit or explicit agreement between the two authorities, fiscal and monetary authorities, about if the share of debt. There's not going to be any conflict about the share of debt. That's simplification. I think it will be interesting to see what happens if there is more disagreement between among policymakers. But the idea here again is to have to show that this fiscal zero trend inflation can explain the bulk of persistent change in inflation. In the 60s and the 70s, there is a persistent and partially unfunded rise in transfer that accounts for the trend inflation, the low frequency movement in inflation during this period in which inflation will be remarkably higher. And later on, this partially unfunded debt has been mitigated, but it hasn't completely disappeared, and that helped to offset the deflationary bias from the 1990s and on, which a period in which inflation has been remarkably low, especially in the last 20 years. in the absence of these fiscal fiscal mechanism, fiscal theory, the model would have predicted much lower inflation in the U.S. In the last 20 years. And finally, we look at the effect of ARPA fiscal shock and all the fiscal response to the pandemic, which has been pretty extraordinary, I would say, in terms of the size and the numbers of these interventions. And we show that according to the model, this response moved beliefs about the share of unfunded debt that that's outstanding right now, and this increased trend inflation by about 1%. So some implication of this result are the following. So when when government debt is large, this can create some constraint for monetary policy. Okay, because again, we don't get into this constraint in the sense that what the central bank can do. We are not normative about this, but certainly when you have the spending is large and debt is large, the police can coordinate on the amount of debt that is unfunded. And this can lead to large swing in trend inflation. And historically, this share has been moving pretty sluggish. I'm going to show you how this share moves over time according to the model. And I'm going to show how the data, what feature in the data identify this movement. But it is not certain that this swing can happen much more dramatically in the future, because debt is pretty large. Okay, by any historical, the government debt is is one of the largest. It's the largest. It's an historical record. And if you look at the CBO projection, there are certain forecasts. This debt is not expected to stabilize. In fact, it's supposed to increase in a pretty dramatic way. And so this paper tried to stress the importance of fiscal credibility to stabilize inflation. You want to have a consistent fiscal framework if you want the monetary authority to stabilize inflation, to keep inflation low and stable. In the absence of this fiscal credibility, it becomes extremely hard for the central banks to stabilize inflation around its desired target. So in a sense, when the central bank announce a particular target, we need to make sure that also the fiscal authority does its part, and there are credible fiscal plans to stabilize the fraction of fiscally funded debt that is compatible with this target. And we have this factor, this persistent shift in the Phillips scale that we interpret sort of like the non-policy forces that move inflation in the long run. They may reflect, a rising geopolitical risks or demographic or other long-run or structural changes they may have in the society and in the geopolitical field that can basically determine determine change in inflation. And of course, if this geopolitical is are to change in the future, of course, you need even more ambitious fiscal adjustment to allow the central bank to stabilize inflation around the 2% target that has been adopted. So let me introduce the model. I don't have time to explain all the details of the model. The model is a tank model. It's pretty standard. We have distortion taxation on labor and capital income. So basically, when you have a increase in spending that is funded, still it isn't expected that at some point the fiscal authority will raise taxes, distortionary taxes on labor and capital income, and that's an effect on the economy. There are hand-to-mouth households to break the Ricardian equivalent, and there are long-term government bonds, okay, to make the propagation of the effect of unfunded fiscal shock more realistic. And there is a typical set of business cycle shock plus fiscal shocks, and the shifter or the persistent shifter of the Phillips curve that capture market and non-policy forces such as globalization, geopolitical risk, and demographic changes in our model. there are two types of transfers, Shop. Okay, so there are type of transfers. So they are funded transfers. These are transfers that are backed by future fiscal adjustment, and for the the macroeconomic implication of this change in funded transfer, the monetary and fiscal authority follow what we call a monetary-led policy mix, which means that the monetary authority will apply the Taylor principle, will respond strongly to inflation deviation from the target, and the fiscal authority is committed to adjust, to make the necessary fiscal adjustment to stabilize the resulting change in the government debt. There are also unfunded transfers. Okay, and the unfunded transfers are the new guy in town. They're the new shock that we started in this paper. And with respect to the change in inflation and output and resulting from in the data resulting from this unfunded transfer, the monetary and fiscal authority coordinate in a very different way. The monetary authority will disregard the inflation consequences of these unfunded transfer, and at the same time, the fiscal authority is not expected to adjust its fiscal tools, taxes and spending, to stabilize the increase in debt resulting from this unfunded transfer. The change in these unfunded transfers. So the monetary authority, in a sense, tolerates the increase in inflation needed to stabilize the result amount of unfunded debt. So how to implement all of this in a DLG model? So we have basically two types of change in transfer, zeta MZT and zeta FZT, that determine the share of funded and unfunded debt. Okay, so the funded share of debt, which is denoted by B tilde MT, is stabilized by fiscal instrument. Okay, and the fiscal trend inflation, pi hat FT, is the increase in inflation needed to stabilize the unfunded share of the debt, which is given by the total amount of debt in deviation from linear deviation in deviation from steady state, B tilde T, minus B tilde MT, which is, as I said, the funded share of the debt. So this difference here is this difference here, as you can see, is basically the share of unfunded debt. And for this share of unfunded debt, everybody, but the policymakers agrees, and the private sector expect that this share will be stabilized using an increase in inflation over time, which is denoted by this pi hat FT. So the monetary authority only responds to deviation of inflation from this endogenous trend. It can be inconsistent, as I said at the very beginning, with the announced target. That's a problem for the monetary authority. Okay, but this trend, this endogenous trend, is time varying, and it depends on the size, on the unfunded share of debt, which is given by this different BT minus BMT. And in order to track or to pin down the dynamics of the funded debt and the fiscal trend of inflation, we introduce a shadow economy, which is a parallel universe that is in which the policy mix adopted by the monetary and fiscal authority is the monetary-led, meaning that the monetary authority is committed to stabilize inflation around the target, and the fiscal authority is committed to adjust taxes and expenditure to stabilize the debt in the shadow, the government debt in the shadow economy. And of course, in this type of situation, importantly, we shut down in this parallel universe the shocks to unfunded transfer. When you shut down the shock to unfunded transfer and you assume this policy mix, basically the whole public debt in the shadow economy is funded because there are no by construction, and the Taylor principle is satisfied. So the inflation rate, that would be like the dynamics of the debt in the shadow economy. You're going to get the dynamics of the debt and inflation in the counterfactual scenario in which all debt will be funded. Okay, and that's important for us because then when we go to the actual economy, we can write the fiscal rule policy rule that the fiscal authority follows in terms of the amount of unfunded debt, because the authority, the fiscal authority, will have a different response to unfunded debt and unfunded debt. In fact, it's not going to respond. It's not going to respond at all. It's not going to adjust taxes or government expenditure to the difference between the debt in the actual economy minus the debt in the shadow economy, which is denoted by a PMT. And inflation in the actual economy is basically the sum of the inflation in the shadow economy plus this amount. Pi t is the inflation in the actual economy, and it can be decomposed by in terms of pi m and pi f. Pi f comes basically comes from the shadow economy. That's the inflation the central bank cares about, and pi f instead is inflation the central bank is not responding to, because it wants this inflation to stabilize the share of unfunded debt, BT minus BMT. And so basically, by letting this pi ft, this you can, as I said, that you can interpret an endogenous target, as you'll see in the next slide, by letting PFT to move to stabilize the share of unfunded debt, the central banks allow persistent moving inflation, and in fact introduce some fiscal trend to inflation dynamics. And policymakers, it's very important, do not respond to the amount of unfunded debt and fiscal trend inflation. The amount of unfunded debt is that, right? It's defined as a difference of between the actual debt and the debt in the shadow economy, which there is all debt is funded, and the monetary authority does not respond to fiscal trend inflation, which is given by this pi ft. So to put this in math, so basically you're going to write fiscal and monetary rules as follows. So you're going to have that the government adjusts G, the government purchases, transfer, and tax rate on labor and capital income to respond to the debt in the shadow economy, which is the debt basically that the share of funded debt. Okay, for that amount of debt, for the fiscally funded debt, the fiscal authority is committed to and is expected to adjust its fiscal instruments to stabilize it. There are these two shocks. One shock is the shock to transfer. It stands for transfer here, and this shocks basically. This shock is the shock to funded transfer, and in red is the shock to unfunded transfer. So basically, in the shadow economy, you basically shut down the shocks over here. And then these are, of course, the roots in the actual economy. And then you have a monetary rule that is subject to the zero lower bound. And here you can see that the central bank has a different target. Okay, it doesn't have the target the central bank is having is an endogenous target. So the central bank adjusts the nominal interest rate R only to deviation of inflation from the fiscal trend inflation, okay, which is the amount of inflation needed to stabilize the unfunded share of debt.
Leonardo, can you explain why this is needed? So why don't we want to model the monetary policy according to what they say they do? I mean, what they say is they want the inflation target to be 2%. They don't say we're going to adjust that as fiscal needs change.
Okay, so if you do that, then you leave the word of coordination. That is the easy and simple word we are considering here. Okay, so if you suppose, so you can have a situation in which you instead of having pi ft, you basically have 2%. Remember that we are not talking. So here we're taking a more holistic view. We're not talking about the post 2012 when the inflation target has been introduced. We are talking about also the 1970s, and this potentially mechanism to explain the 1970s. And this can be a mechanism that can explain, and that's what I like about this theory, is that it can explain that even though the central bank announced 2%, effectively the central bank here cannot stabilize that inflation of 2% if it doesn't have the fiscal backing. Okay, so now implementing, so I can stick 2% here, and if I do 2%, I can do that. But inflation will never go back to 2%. because it's simply the fiscal authority, the fiscal framework is not consistent, is inconsistent with stabilizing inflation around 2%. Okay, so I could do that. I could say here you have 2%, but then you introduce a bias in the monetary policy. Okay, yeah. So this the empirical analysis, we have a wealth of time series. We have standard macro time series in black, I would say. We have in red, I highlighted in red the fiscal time series. We have the real transfer payment growth rate, the real government consumption investment growth rate, and the debt to GDP ratio. We also have a market expected federal funds rate that helpful to model the ZLB. Agents are never surprised to see that the central bank is subject to this non-negativity constraint for the nominal interest rate. And we split the sample before and after the Great Recession. In the new version of the paper, we are merging the sample. There is no particular reason. It's just because we introduced these additional time series for the expected market path only starting 2008. That's the only reason we have this split. But we don't have to do that, and I can tell you the result when you don't do this, when you don't make this assumption are very, very similar, almost identical. We have so in the second sample, as I said, we have more observable. We from the 2008 Q1 we introduced also this term structure of the this expected market path of the federal funds rate coming from the US data that basically makes sure that in the data this data do not violate the ZLB, and so basically we have a set of new stock appended to our monetary policy rule that makes sure the agent understand there's going to be that the central bank has to respect the zero lower bound constraint. So in the estimated model,
Leo, can I ask real quick?
Sure.
So the transfers then you're using realized transfers, is that right?
Right. Yeah.
I see.
Yeah.
So you're thinking of like there's a shock and agents sort of like perfectly forecast what the realized transfer. I guess there's just no data on some expectations of what the fiscal surplus is going to be in the future. That's what you'd want in the model, I guess, right? Yeah. I mean, I'll show you in a second how identification works. So I think your question is a very good one, Zach. So how can you really, Leo, how can you really distinguish between the funded and unfunded, right? Since you only have transfer. Yeah. In this slide, I can give you some hints. It comes from the cross movement in cross correlation in the observable I use. So these are of course this is based on I do this impulse expansion around the posterior mode, so at the estimation, but this gives you a bit of a sense of how the likelihood can, how the model basically can disentangle funded versus unfunded shares of transfers. So basically here we have the impulse response function. Start first with the black line. This is the funded transfer. The response of inflation, real interest rate to this funded transfer, even though remember I have distortion in taxation, are quite small compared to the other the effect of the other two shocks, the unfunded transfer and the Phillips Scar shifter, which is in red, on inflation and real interest rate. So what the unfunded transfer does, what shocks to funded transfer do, they basically increase the debt to GDP ratio. Okay, but they have no measure effect on inflation, the real interest rate. The real interest rate goes up a little bit because remember the central bank want to respond to this inflation, increase in inflation, resulting from an increase in funded transfer. Because for that type of inflation, the central bank is committed to follow the Taylor principle. What happens when you have a shock to the unfunded transfer? Yeah, you can see that inflation increases in the short run, but also in the long run. It doesn't. These are 10 years, okay, horizons. There's a longer horizon. Inflation tends to remain high, and what happens is that the real interest rate will go down. Okay, the real interest rate goes down because the central bank
overlooked, is not committed to respond to this inflation. So it doesn't raise the nominal interest rate according to the Taylor principle. So the real interest rate falls. And most interestingly is that the debt to GDP ratio falls. Okay, so in order to identify, so what the likelihood to see in the data to, pick the unfunded transfer shock is the following. You see, you must see inflation going up and stay high, okay, persistently. You should see also the real interest rate to go down, remain persistently low. And you should see the debt to GDP ratio fall. I pretty much describe what happened in the 70s, end of 1960 and 70s. The 70s was a period in which inflation was high and was rapidly up, and every period it went up. Right? And then when it fell, like think about the 1973, 1974 oil shock, inflation went up, and then when it landed to a higher level than the level it took off, okay, before the shock, the oil shock. And so it started increasing. The debt was very low, that GDP ratio was low, and the real interest rate was, extremely low, okay, was very low. So that's the 70s. So that's a shock that seems very well suited to explain that period. The fiscal shifter produced a temporary inflation spike and some, it's the red, and some persistent inflation later on. The real rate goes up, however, and that increases. Okay, so the model with the data I use is very able to distinguish between these three shocks. Okay, based on the movement, the cross correlation, more correctly, of inflation, the real interest rate, and the GDP ratio. So let me show that basically 4 phases of this transfer. Okay, so here what I show is the cumulative change in total transfer, which is the red line in these 4 plots that break our sample in 4 periods, 4 sub-periods. So the red line are basically the data. Okay, so the red line is basically given by the data. The data I use based on the change in real transfer. And you can see that in the 60s, these are deviation from the steady state in the model, but they are the cumulative changes. You can see that there's been a substantial increase in transfers. Okay, and there's been part of this increase in transfer has been tended to be unfunded, which is the gray, is denoted by the gray bars here. So that's the period in which this large increase in transfer that are mainly associated with the introduction of Medicare, Medicaid, the Great Society Initiative, that are very long-run spending program that have been launched in the first half of the 1960s, but were mainly implemented in the 60s and the 70s. Pushed transfer, increased transfer quite a lot, and part of this transfer has been seen by our model, as an increase in the unfunded schedule. So there is no expectation that the policymaker would have adjusted taxes and the interest rate to respond to the macroeconomic consequences of these increasing transfers. These things, then from 1975 through 1990. Transfer being pretty much stable. You can see the red line here went down in the second half of 1970, but by and large, been pretty stable. And you can see that in this period, there was a substantial stability in the share of unfunded transfer, but it follows an interesting hump shape exactly when the fork of disinflation happened. And in that period, in the paper, we spent some time talking a little bit about the narrative about where the gray bars peak here. In that period, there was also the election of President Reagan that provided a strong fiscal backing to the central bank. So I adjust the fiscal framework to provide backing to the monetary authority. And that's, in our opinion, is one of the most important changes that's been done on the fiscal side. Whereas before that, the fiscal policy was not well positioned to allow the central bank to stabilize the inflation rate, because the target, the implied, the fiscal trend of inflation was too high. It was growing. because of this dynamic over here in the 60s and 70s. What happened in the 1990s? In the 1990s, we have quite a substantial rise in total transfer, but as you can see, beliefs about the unfunded share of this transfer being very stable until the Great Recession, and it increased after the Great Recession a tiny bit. In the most recent period, these are the pandemic period. You can see there was the first fiscal response in 2022, the first fiscal response to the pandemic, where many Americans receive a check in the mailbox, and it's captured by this increase in total transfer. And the model C didn't react very much here in this particular first fiscal stimulus. More toward the end of the sample, toward the end of the last observation in our sample, we can observe some increase in the share of unfunded transfer. So that's what happens if I want to interpret and want to decompose the dynamic of inflation in the data, which is the red line, in terms of unfunded transfer shocks, other policy shocks, and non-policy shocks. Well, you can see that in the 60s and the 70s, and in the decline following the 1980s, the unfunded shock to unfunded transfer playing important roles. Okay, of course there is this large spike in inflation in the 74 and later at the end of 1970s. These are basically due to non-policy shock. These are basically a mix of cost push shock and the demand supply shock that determines this type of shock. That explains this type of dynamic in the model, not the unfunded transfer shock. And then this unfunded transfer shock, however, the contribution to inflation, the contribution of this unfunded transfer shock to inflation didn't disappear, remain quite substantial, offsetting the contribution of this non-policy shock that we interpret as everything that is not accounted by the policy shock, which again can be geopolitical risk, can be globalization force, international trade, and else. And you can see the dynamic of inflation has been, there is a lot of offsetting. There is an offsetting between the fiscal shock, the unfunded transfer shock, and these non-policy shocks. And we argue that basically mitigate the persistent, deflationary pressures that we have been observing over the last 30 years. So here, what we do, we look more at the.
Leonardo, I have a question here. So I feel like when you're talking about unfunded fiscal expansions and how that can cause, fiscal theories of inflation in general, I mean, the US isn't the first country that comes to mind. How about, have you been looking at all the other countries that have been experiencing high inflation, and obviously where, Surgeon and Wallace and all the other ones connecting it to fiscal causes?
Yeah. So you're referring about the 1970s, I guess, when you say high inflation.
Well, there's the other developing countries in the 1970s, and there's Latin America in the 80s. I don't know if there's data for Hungary's hyperinflation, really, maybe not.
Yeah, no, I mean, we don't want, I think hyperinflation, this is consistent in all these countries, but in developing countries, when inflation, goes off the chart, right? It's most likely associated with the fiscal situation, with the fiscal framework that is not consistent.
But not just the off the chart. Let's say, Argentina 20 to 80%, Turkey 10 to 50%. Those kinds of inflations rates, right? I mean,
no, we haven't
common experience.
We haven't tested the view on that. I mean, I think it will be interesting to understand for this type of country where inflation increases in a more substantial way than in the US. I think what will be interesting to understand a little bit better and to test this theory, which I think is more sensible for a country like the US. Okay, but in other countries, maybe more like a situation in which we have a de-anchor over inflation. Okay, that is more like a sunspot type, or this type of theory. That I think will be a good test. For the US, I think, which the government debt is issued in their own nominal in the national currency. There is no risk of default on the debt, perceived risk of default on the US debt. In that country, I think this theory is very useful because the idea that only a fraction of debt can be stabilized with higher inflation, I think provide a sort of like a way to generate increasing inflation that are moderate. Okay, so nobody really think that all debt will be inflated away. Okay, they may think for countries like the US and advanced economies that the fraction of this debt will be inflated away. And then if you are like a market participant, they have to decide whether to buy the stock of debt, and you don't think that the government will be willing to raise enough taxes to repay the piece of paper you bought on the market, right? Then, and you don't think either they're gonna be a formal default on this debt. Then what you're gonna expect is that monetary and fiscal authority may coordinate to generate some inflation. How much it depends on the expectation of how much the stock of debt is unfunded. That's a little bit the story here. And in the paper, more than in the presentation, we work hard in explaining the narratives that back this what I'm showing you here, all these dynamics of the black bars. But I think one thing we like about this is exactly that it's more applicable to the US. A previous work I've done with Francesco, and it was based on regime changes. When you have a regime change, you expect that the large chunk of debt will be inflated away. And if you do that for the US with such a large debt, or for a country like Japan, you're going to get a huge increase in inflation that is totally counterfactual. I think this theory is substantially is more tailored to countries that have experienced moderate inflation, and the fiscal reputation is relatively strong. Does it make sense?
Yeah, perfect. But I guess a country that would also at least sound like the UK, for example.
The UK is interesting. You're right. I agree with you. No. I don't push back. You ask a very good question. I think we should do more work on the like an international comparison on that. I didn't mean to push back. I just want to make the point that the improvement here compared to what we have been done in the past, which mainly based on regime changes. Here you don't involve any regime changes, just changing expectation of how realistic, how plausible it is that the US government will, raise taxes or adjust or reduce spending to repay the large stock of debt. How likely is that instead some inflation will kick in to stabilize this the large fiscal imbalance. To conclude, I've just a last graph to show. Here, what we do, we look at the most recent period, and the data. My data set stopped in 2020 Q4, and so basically, what we do here, we just take the 2021 Q1 data on transfer payments. In that period, there was being the ARPA fiscal shock. They basically sent another round of checks to many Americans, and this was accounted in Q1. That's important. So they were sent most of these checks were sent in March. So we take the number of the increase in transfer in 2021 Q1, and then we use basically the filter. So we use the traditional, historical ratio over which the model has split the increase in transfer. So the model would interpret this increase in transfer due to ARPA, and the estimated model is going to distribute this increase in transfer into funded and unfunded based on what has been historically estimated. And the result is and then we launched the forecast conditional on this repartition of the ARPA fiscal shock into funded and unfunded transfer. And the forecasts are basically the red line over here. The blue line is the forecast unconditional, so without including the ARPA fiscal stimulus. Okay, so we just say, okay, we sit in 2020 Q4 and we ask the model to forecast hours, interest rate and inflation. Hours is a proxy for output gap generally. That's the reason why we use hours. Aesthetically, but cosmetically, probably we should show the output gap. It wouldn't change very much. And the stars here are basically the data, the GDP deflator that we observe in the last year. And the bands, the pink bands here, basically we play around a little bit. As I said, we take the increase in transfer due to the ARPA fiscal shock, and we use the historical estimated ratio between transfer and between funded and unfunded transfer. The bands are basically play around a little bit with this ratio by increasing the transfer, the ratio of unfunded to funded transfer by 5% or plus 5% or minus 5%. And we get these bands that basically give you a sense a little bit on what will happen if this historical ratio is changed. And a large amount of ARPA transfer will be unfunded or with respect to the historical estimation. And then you can see here that inflation is, the model will explain why inflation went up and stay up. And to some extent, you may interpret the large increase in inflation that depends on many things, supply constraint and other stuff, at least in part explained by this fiscal component. And what is interesting, in the long run, you can still see that, they compare, for example, to the pre-ARPA, you add 50 basis points to long-run inflation based on these ARPA fiscal stimulus. If I use the historical, the estimated ratio based on historical data, again, this thing can be higher because of, with ARPA, you may signal that policymakers are willing to change the share of unfunded debt. And so just to wrap up here, this paper, we want to emphasize that, if inflation doesn't converge to the desired target of the central bank, may not be the only, it's not only a problem of central bank's reputation. It's a more complicated problem if you want to understand, involve both the credibility of the monetary authority and the credibility of the fiscal authority. And when spending in particular is large, beliefs about the shadow of that is unfunded may lead to large swing in trend inflation. Historically, this swing has been particularly sluggish. Remember, I showed this graph with these gray bars that decompose the cumulative changes in transfers in the data. But that there is no certainty in the future this thing can change, and you may have a abrupt change in the share of funded or unfunded transfer. And again, the problem here is really that the debt is large and it requires some fiscal adjustment going forward, important and massive fiscal adjustment going forward to be stabilized. When the debt is low, there's substantially less risk that changing beliefs would generate persistent change in inflation. So the bottom line here is that monetary fiscal coordination is very important when it comes to control inflation, in particular in the long run, the low frequency dynamics of inflation. In particular, the fiscal authority needs a credible plan to stabilize the fraction of fiscally funded debt compatible with the central bank's target. And the central banks can only credibly commit to limit inflation deviation from that target. Again, there was an interesting question before saying what the central bank doesn't do that. I think we should probably show what happened. But the central bank cannot really push the long-run inflation to the desired target unless the central bank has a fiscal backing, or at least a fiscal framework that imply that the share of unfunded transfer is in line with the target. And I want to say that this doesn't mean zero unfunded transfer, okay? Remember what happened. I show you this graph with the composition of inflation. In this period where you have persistent deflationary pressure, okay, coming from a policy shock, in order to keep inflation to stay afloat, right? You want to have some fiscal inflation. So it's not true the optimum. You want to have a zero unfunded transfer, okay? Sometimes to allow the central bank to stabilize inflation around the target, you need to have the right amount of fiscally unfunded debt, okay? That's important for the central bank to stabilize that. And perhaps announcing a target may be a way to coordinate expectation about the unfunded transfer. That's something very interesting to understand. It's a very hard question, but I would like to work more on this in the future. And to conclude, the last point I want to make today is that if you think that there is not much doubt about that geopolitical risks are on the rise, then you should expect that this fraction, the white part here, the non-policy shock, may actually become smaller, and therefore you need even more ambitious fiscal plans to allow the monetary authority to control inflation around 2%. And that's all for today. Thanks a lot.
Thank you so much. Yeah, we just realized that we accidentally on the posted schedule put you in for 45 minutes. That was definitely not the intention. So if you want to talk for 9 more minutes, please go.
I'm fine. I'm happy to conclude earlier.
I can ask you another question. So I was wondering,
please,
what part of your,
I think it's much more given the framework is virtual.
What part of your results actually depends on the tank model? So what can't you get in the rank?
That's a good question. The reason why I didn't emphasize that, let me explain why I like to have a tank. I don't do that just because I want to flex my muscle and say, man, I know how to solve this model. I do that because there is, we are not the first people saying that, fiscal may be behind to the current increase in inflation. I mean, the more prominent scholar than us, Summers and Blanchard also said the fiscal policy has to blame to overheat the economy and inflation to go up. This mechanism in our model as well, right? Because basically you may have that you can have temporary effect of fiscal policy that create a negative output gap and push inflation up. So that's the reason why we want to have this. In previous work with the different mechanism, now with the unfunded share of that, we also have a representative agent model. The problem that you have Ricardian equivalent. So in that sense, if you have no distortionary taxation, what happens is the funded transfer shock has zero effect on the macroeconomy. That's something you can prove. And it's very extreme, and that's the reason why we think is important. This is a positive paper, Luca. So we won't really.
No, I understand. Maybe I don't understand the representative agent model well enough. In the kinds of models I work with, the debt is usually
because there is basically a Ricardian equivalent.
If there's debt that isn't paid through taxes, it has to be paid for with inflation.
Yeah, you can introduce, so basically, if you have a representative agent model and no distortionary taxation, okay,
right, of course,
you have zero effect whatsoever, right? So the fiscal block is completely isolated from the macro block, so to speak.
If you have
so basically, taxes, and this is basically when we, if you take, for example, standard DSG model like, Smets and Water or Cristiano, Akan, and Evans, they have a fiscal block, but they have some assumption, if you exclude the possibility, so if you focus only on the monetary-led policy mix, as they do, you have no distortion in taxation. Suppose you take the model to fiscal data, they don't play any role. They are complete dichotomy.
Isn't the definition of an unfunded shock an increase in debt that they're not willing to raise taxes for?
Oh yes, if you have unfunded, yes. So if you have unfunded shocks, or you have some sort of coordination away from the standard policy mix, yes, you can have some effect. On inflation, which I believe that not be too different from what I show you today. But because the mechanism is different, and the mechanism through which this operates, this fiscal mechanism operates, is really, if you think about the Phillips curve in the model, it doesn't operate through the marginal cost of the output gap. It really operates in terms of the long-run inflation expectation. That's how it operates. It doesn't operate through the distortion taxation or the fact that you create some temporary effect on the aggregate demand. It's really about the fact that there is there is an increase in the stock of debt that is not intended to be stabilized with traditional fiscal instruments, and you need inflation to do so. Agent internalize this, and inflation, the Phillips curve shifts forward. Okay, that's really the mechanism. So having or not the distortion taxation, of course it matters, but I don't think it will be decisive. I don't think it will change pretty much the result that I show you today, precisely for the reason that most of the mechanism is at the level you have a long-term, you have a debt that has to be repaid over a number of periods because it's long-term debt. And there is expectation that inflation will be used to stabilize this debt. And that's really the key mechanism, rather than distortion taxation or not. Distortion taxation add the realism, improve the fit of the model.
So with that in mind, since you just hinted at that, does the maturity of the debt matter for your story? I suppose if it was, I remember U.S. Treasuries had an average maturity of 7 years, if I recall.
I don't remember exactly. We calibrated.
It might be longer now. This might be data from 10 years ago.
It's about right. I think it should be probably 6 years or 7 years. I don't remember exactly how we calibrate. It's a calibrated parameter.
But I guess your model does imply that inflation can increase over a 10-year, 20-year horizon. So it doesn't have to be all happening within the average maturity.
It may, because that's an average maturity, right? So it may generate. Plus, in the model, there is also some persistence. So the model has a lot of real frictions that generate, other dynamics. So it may go beyond 7 or 8 years. But there are two things that help the persistent effect. One is the duration of the debt, and the other thing is the nominal rigidities, Lucas. Okay, because also if I remove nominal rigidities, I'll have like an increase in the. So for this mechanism to be there, of course, to have inflation or changing price coming from the debt, you don't need to have a nominal rigidities. But to get the persistent that we want, nominal rigidity help a lot. Okay. Plus the maturity of the debt. If you have like one period debt, the effect on inflation will be much more short lasting.
Right. All right. Thank you so much, Leonardo.
Thank you.
Any other questions from the audience? It might just be that this is the curse of virtual seminars. At some point, everybody, I mean, at any seminars, at some point, somebody wants their coffee break. And with virtual ones, you can take it at any time. Thank you so much, Leonardo. And we're excited to have our last presenter, Zach, presenting about unemployment, inflation, and the distribution of liquidity. So I guess we'll see the more heterogeneous agents content for our last talk.
All right. Great. Thanks, Lucas, for putting us on the program. Guillaume sends his apologies for not being here. I think he was on the program. I'm gonna present the paper. This is the paper on the relationship between inflation and unemployment in a model where the wealth distribution will matter. So what are we asking? You have to think about a short run and a long run, and we have several papers we're looking on. And in this paper, we're going to focus on the long run. And so that sense, we're really addressing one of the oldest questions in monetary / macroeconomics, is inflation that's produced by some money creation. I'll talk, exactly what money creation looks like in our model. Is it neutral in the long run? There's a longstanding belief that there's neutrality, dating back to Friedman, but even re-upped in Holland Sargent's JPE article in 2018. That you have essentially a vertical long-run Phillips curve, right? No relationship. Empirically, this is a challenge to figure out what is the long run, and if there's neutrality in the long run. The evidence is mixed. Some find no effect, neutrality. Some papers find a positive, a negative effect, but the consensus has really been across macro that there's no long run effects. Let's focus on the short run effects, right, of monetary policy, money creation on the macroeconomy. Now, we really think this has led to, people not paying as much attention as should we care about the long run effects as much. And, part of this project, we, want to motivate that this is an important question to ask. Of course, if you don't have neutrality, or even if you do, you want to understand the channels about how inflation in the long run, which you'll see is anticipated inflation, affects households, affects the macroeconomy. It's certainly important for things like the long-term inflation target, other long-term monetary policy goals. If it's neutral, should we really think that that policy should focus on short-run stabilization? So that's the world we're going to think about, or the types of questions we're going to think about in this project. So we'll study the relationship between inflation generated by money creation and unemployment in the long run. We're going to pay a lot of attention to the aggregate, but it's going to be a model with, a rich wealth distribution, multiple assets, which you'll see. So we're also going to think about to what extent does, the shape of the long run Phillips curve help us understand about redistributive effects of inflation in the long run. And we'll also ask some normative questions about welfare. What's the optimal long run inflation target in our model? Okay. So a little bit of the mechanism before we get in, people who have seen kind of the, new monetarist monetary literature that I tend to work in will be somewhat familiar with this. If you haven't, the primary mechanism of how inflation is affecting households is through the inflation tax, right? You'll see the model is not going to have any nominal rigidity. So the primary real interest rate that means that households really care about inflation is going to be the fact that they hold some assets that are giving close to zero nominal return. And so inflation is going to really dictate what the real return on those assets are. If you add to that a model where money, these liquid assets are useful for consumption to some extent, households face liquidity constraints, the inflation tax is going to reduce households' holdings of liquidity. Why does that matter for the macroeconomy? Well, consumption falls. We're going to get essentially what looks like an aggregate demand channel. The demand for firms' output falls. That's going to increase unemployment in the long run. And this is, building off the paper by Berenson, Menzies, Wright in 2010. Of course, that's going to give you a positive relationship between inflation and unemployment, a positively sloped Phillips curve. What we're going to add to that discussion in this paper is to recognize that there's now a broad literature that thinks about, well, once you start taxing wealth, households with different income and total wealth levels or different portfolios respond differently to that. Importantly, they're going to respond differently in their demand for assets, including liquidity. They're going to respond differently for the demand for consumption. So it's going to matter that we capture those responses, and consistent with the wealth distribution that we see in the data. That's going to help us discipline this effect of this aggregate demand channel that we'll have. But once we do so, once we take seriously that households are holding different types of assets, they have different wealth levels, income, et cetera, that also implies that we get some asset substitutability roles. And one channel we're going to be thinking about in this paper is how, if I tax liquid wealth, how does that affect households' portfolio choices to shift away from those liquid balances into other less liquid balances, including things like the claims on firms, equity, which means we're going to have a financial discount rate channel that's going to affect unemployment in the model. You'll see the model is relatively simple, even though we capture a bunch of these different channels in the following sense. On the firm side, it's going to be vanilla Diamond Morton simplicity. Firms respond, create vacancies, respond to the expected value of filling that vacancy and producing some output. So if that object changes, and they'll discount the future at the market discount rate that they face. That's what's going to determine pin down unemployment. It's going to be, really derived through that firm free entry condition. On the household side, it's going to look like a Bewley model with multiple assets. The difference here is how we think about really embedding households' need for liquidity. And you're going to see we follow the new monetarist literature or the Diamond-Dybvig literature and think about households have these two different types of consumption. There's some kind of normal consumption goods that are anticipated. And there's other consumption goods in which they face some expenditure risks, some liquidity risks, really preference shocks. And that's going to generate a need to hold liquid assets. We're going to endow those households with different types of assets that are going to differ by their liquidity, and then in equilibrium will differ by the rate of return. In the quantitative model, I'll show you, we include things, money, or like things like checking accounts, but also government bonds, housing, claims on firms. Okay. So if you have to run before I finish, let me just give you two key takeaways of what we're doing in this current, of what we find in this current paper. The first one is really just asking the question of, can this model, which has a lot of the features of like a Hank type model, but with no NK part, really like a monetary part with liquidity constraints, can that match features of the household wealth distribution, household level elasticities, et cetera? And I'm going to try to convince you today that it does well. It matches those features well. But let me give you some examples of that. We're going to endogenously in our model get that there's some measure of households that hold only liquid wealth. Right? They put all their wealth in the most liquid assets that are offering the lowest rate of returns, and they're not holding any claims, bonds, housing, et cetera. Once we start seeing households hold wealth in the model, we'll see that if you increase their total wealth or increase their income, they're going to shift away from liquid assets and towards the less liquid assets. That's also consistent with the data. So you get a portfolio composition effect across the wealth distribution that their assets are changing. So that means financial assets are predominantly held by these high wealth households. And then we could ask a bunch of household level elasticities, things like NPCs. How are households responding to job loss as a function of their wealth and their income? And we see that's also consistent with what we see in the data. How do households respond to some kind of like long run measures of asset prices or returns? So I'll try to convince you that this is a good laboratory quantitatively to study things like money creation, et cetera. What do we find in terms of the Phillips curve? All this discussion about is it neutral, is it not neutral? We're actually going to find that it's relatively neutral. We get a Phillips curve that's essentially vertical in the long run, but that doesn't mean in the model that inflation is neutral, that money creation is neutral. And it's because even though it looks like we have neutrality, that's really hiding really two strong channels that work in opposite directions. The first one is this aggregate demand channel I explained. You tax liquid wealth, that decreases aggregate demand, that increases unemployment. That gives it a positive relationship. The other channel is this interest rate channel, that asset substitution is strong. If you increase this long run inflation, households substitute away from liquid balances towards less liquid balances, including claims on firms, that increases asset prices, lowers financial discount rates, that decreases unemployment. That's a channel that decreases unemployment. Now we find in the calibrated version, these two just happen to cancel each other off. But then we're going to do a bunch of counterfactual experiments to say, well, what if either the way we finance inflation changes? How does that affect the strength of these two channels? And I'll try to argue it depends on the distribution of what we call effective liquidity, which we can think about the distribution of wealth, where we take into account how liquid each asset is. Okay. Eventually, we can ask, the normative takeaway here is we find that inflation can be welfare improving. In fact, moderate inflation up to 5%, and that we'll focus on, and the normative stuff, just helicopter drops, lump sum transfers of money, can benefit aggregate welfare. And that if you do helicopter drops, inflation is actually going to be more costly for the higher wealth, which is somewhat counter to what most people think, largely coming from these transfers, though. However, it's also more costly for the unemployed. I'll explain where that comes from. Okay, there's a huge literature. Let me skip it. We could talk about it after if you're interested. Okay, so the model. The model, again, is going to be this kind of Bewley model on the household side, more in simplicity is on the firm side. The key kind of new feature that you may not be familiar with is what are these two types of goods, right? Otherwise, it'll look like a standard Bewley model. So households, we're going to think about two different types of consumption goods. I'll call Y the early consumption good, C the late consumption good. It's technically a three-good economy. There's going to be some housing services in the background because we have housing in the model, but we're really going to break apart the fact that you could rent housing separate from how much housing equity or wealth that you have. I'll explain that in a minute. So each period of the model is going to be broken up into three different stages. The first stage would be the frictional labor market, matching of unemployed workers and vacant jobs. And then some households are going to experience some expenditure risk, or some liquidity risk, where they have a preference to consume early. And the key here we're going to think about is that If households have to consume early, they have to finance that. They face some liquidity constraints with liquid wealth. I'll be explicit with what those constraints look like. Everything's competitive though, so they face some competitive market price for early consumption in terms of numeraire. We'll see. We're going to allow this late consumption good to be the numeraire, and so subject to their liquid portfolio, they can consume in that early period, and then they move on to the final period where they receive their wage, capital payments, et cetera. They make portfolio decisions for the future, and there's a competitive goods, asset, and housing market. That's on the household side. Why that's going to matter and how we generate these two different types of consumption goods. On the firm side, firms are going to face, a firm that's matched with a worker is going to face some generic production possibility frontier. And so we're going to see the relative price for early consumption. We're going to think about, firms can produce some amount of early consumption, some amount of late consumption. That price of early consumption is going to dictate their expected revenue from entering into this labor market and finding a worker, which then is going to feed back into unemployment. Okay, that's the structure. Okay, so here's household preferences. They get some, epsilon is going to capture the preference shock. The probability of getting an expenditure or preference shock is going to be alpha. We'll assume that's just IID across households. Then they value late consumption, housing services. Of course, they may get some value of leisure, so E is capturing their employment state. Here are our assets. We're going to think about 4 different types of assets. We'll think about money. We're going to assume that money grows at some constant rate. That growth rate's exogenous, which means in the long run, we're going to get that the real rate of return on money is going to be exactly pinned down by the money growth rate, which we'll call pi. That's also consistent with what the long run inflation rate is. So in the long run in these models, inflation is essentially a parameter, right? It's the money growth rate. Then we have 3 other assets. We're going to have real government 1-period bonds with a fixed supply with some rate of return RG. We're going to have claims on firms' profits. This is going to be the households can hold some large diversified mutual fund of these firms. That has an endogenous supply. That supply is going to be the fraction of those firms that are actually producing. That's the employment rate in times the value of those firms, which will note phi F. And that has some endogenous return RF. And then there's a stock of housing. We'll assume that it also has some endogenous supply. There's free entry to the production of houses. Similar to, this is essentially symmetric to how we're modeling firms with some endogenous rate of return, RH, okay? We really include housing in the model, not so much for the mechanism, more to be consistent, or at least try to be consistent with the household wealth distribution, okay, across these assets. Okay, here's the firm problem. Essentially the static problem.
Sorry, I think I missed the part where did you say the housing is divisible, indivisible?
It's divisible. Yeah, divisible. Yeah, that's right. Yeah, housing equity is divisible. That's right. And services.
Excuse me, Zach. Can you clarify what the distinction is between money and bonds that's important here? Because I was trying to think about there's sort of some liquid instruments and there are some other instruments.
Yeah.
And this seems like potentially a story about the government managing the return on the liquid instruments to accomplish certain objectives. Is that fair?
That's absolutely fair. I mean, you're going to see in the model they differ by 2 things. One, bonds are real. Money's its nominal object. That's sort of a surface difference. The key difference will be in how we discipline their liquidity. That's right. You're going to see that we're going to allow these to differ in how useful they are in this early consumption, probably in a slide or 2. But otherwise, yeah, you're absolutely right. Outside of the fact one's real, one's nominal, there's no real difference. They're both going to enter the government budget constraint in a similar way, the consolidated government budget constraint in a similar way. You'll see that. You'll see that in a minute. Yep. Okay, so here's firms. As I mentioned, they have this production possibility set. That's a technology that firms face. So they'll have to choose some mix of early consumption Y and some production of the late consumption good. That's Q. And then there's free entry to the labor market with some cost K. Okay, so here's the last slide on the environment. The labor market's going to be random search and matching, Diamond-Morrison Pissarides. There'll be some matching function between some job openings O, some searching workers S. That gives us a labor market tightness and kind of the usual mapping with constant returns to scale of job finding and job filling rates that depend on that tightness. Exogenous job destruction, we're not really doing any kind of interesting innovation on the labor market side. We'll let labor income, either employment income or some income you may get being unemployed, like unemployment benefits, BWE. Here, your labor income after taxes and transfers. So the actual income will let BW bar, after transfers will let BWE. And here we can imagine that you might have transfers that depend on employment status, right? So you could think about inflation that's financed by transfers only to the unemployed. So I guess the opposite way to say that is inflation financed unemployment benefits, for instance. If I have time, I'll show you an example where we do something like that. Our baseline is going to be just lump sum taxation, helicopter drops. But generically, the transfer tau can be a function of E, generically going to be a function of other things. We'll just consider E. Okay, all goods and services markets are competitive. So the market for early consumption is competitive. Households face some relative price of early consumption relative to the numeraire of PY. Housing services will have a price PH. Late consumptions are numeraire. And here's the key way we're going to introduce liquidity. We're going to think about there's some probability that when you get this early consumption shock, only a subset of your assets are going to be accepted in those transactions. We'll call those resellability or acceptability constraints. Okay. We're going to let omega represent the subset of your portfolio of 4 different types of assets that can be used. And then alpha omega is the probability that subset can be used. Okay. So the idea is the following, that you can imagine that in any given period, if you get this expenditure shock, you could always use your money, but with only some probability, you could use your housing equity, or you could sell and use your claims on firms, for instance, or bonds. And depending how we parameterize these different probabilities, that's going to generate liquidity differences across these assets. Okay, and that's what's gonna differentiate things like money and bonds, as Bob was asking, or money and equity, bonds and equity, etc. Okay, any questions about that? All right, so let me kind of quickly describe the intuition of how agents are operating in equilibrium, and then I'll move on to the quantitative part of the model. Let's start with firms. Firms face this job creation decision. They have to think about entering in response to the lifetime value of filling that job. We'll call that phi F. So what is phi F? My lifetime value today is a function of my profits, which would be this Q. Q is going to be expected revenue minus the wage I have to pay. And the lifetime value in the future, assuming that I stay matched with probability 1 minus delta and discounted by the market discount rate RF. Now, importantly, what's in this Q? Q is going to be this combined expected revenue, both from selling in the early consumption market and selling in the late consumption market. As you can see, as I've written this out, I could transform this production possibility frontier to really think about some part of that, what looks like labor market productivity is exogenous, Q bar. And if I shut down the late consumption market entirely, I either assume that households never got expenditure risks. On the firm side, this would almost just be the standard Diamond-Morrison Pissarides model with a fixed labor market productivity. Right? The new part here would be the fact that their return is endogenous. Once I allow for this early consumption, now PY is disciplining that expected revenue. And that's going to really represent what the aggregate demand channel we want to think about is, how inflation affects households' choice of liquidity through the liquidity constraints affects this expected revenue Q. Okay. Once you understand that, mapping it in steady state back to unemployment is kind of the standard logic. Free entry condition gives you a mapping between the future discounted value of having this filled job times the probability that the firm matches has to be less than or equal to their entry cost. So it gives us a mapping between that future value, that firm lifetime value and tightness. And then the beverage curves give you the mapping between tightness and the unemployment or employment rate. Here's on the household side. So again, the incomplete markets consumption savings environment. Part of this will look, a standard Bewley model, except, the portion in the square brackets, which I'll talk about. So we can think about what is the lifetime value of a household. Let me think about that decision at the beginning of the last stage. So stuff that's happened in the past, you've gotten liquidity shocks, et cetera, in the past. Once you enter that last stage, I can just think about what is the value of your total wealth entering into that last stage. I'll let that be A, total wealth. The budget constraint, which we see there, the first constraint is going to be whatever I consume plus whatever I spend on housing services plus whatever I spend on my portfolio for next period must be less than or equal to that incoming wealth plus my income and transfers, W and tau. How am I making those decisions? Well, I understand that I, value consumption, housing services, et cetera, today. But in the future, I understand that my portfolio and my consumption decision today is going to affect my ability to finance these expenditure shocks in the future and my ability to consume and other late stages contingent on my income. Why is that important? Well, households in this model face endogenous income risk, right? Unemployment risk. So they're going to have to think about this decision of what's the total level of my wealth do I want? And also what is the portfolio composition between liquid and illiquid assets? And it's going to respond, you'll see in a minute, to these different types of shocks. We see the liquidity constraints or these acceptability constraints of the second type of constraint and the non-negativity constraints. Okay. So let me just kind of walk through what that decision looks like. I can think about two key decisions. One is once I go into this future period, contingent on my asset portfolio, I'm going to let this A hat be the portfolio, the vector of these different types of assets I'm getting. Chi in this liquidity constraint is just going to be a vector of either 0 or 1s that parameterizes which one of those assets can I actually use, and that's in that liquidity event, right? So Chi could only place 1 on my money, could place 1s on every single one of my assets, which means I can use my entire portfolio. Okay, the left-hand side of that is just the cost of early consumption. So we're going to have to ask, contingent on one of these, on an expenditure shock, and understanding you can only use some subset of your portfolio, how are households making their consumption decisions? And they're simply going to equate the marginal value of consuming early, that's this V prime, with the cost of having less wealth going into that late stage. Of course, households that are less wealthy will face a higher cost because they're going to have even less wealth, right? Things, this lifetime value is concave. And so what that's going to generate is, one, this portfolio, the composition of this portfolio is going to discipline and dictate what they're spending early. Some households are going to use all their liquidity available to consume early. They're going to be constrained, but a lot of households in the model will not do so. They're not going to, quote unquote, cash out. They're going to hoard some of that liquidity, even though they have this expenditure shock they really want to spend, because they understand that's going to affect their consumption savings decision in that late stage. Okay. Here's the household's Euler equation across these different multiple types of assets. The top line looks like a relatively standard Euler equation. Again, they're trading off the value of consuming today with the value of saving. Part of the value of saving in some particular asset J, whether it be money, bonds, et cetera, is simply going to be the expected future value of having that wealth in the late stage. That's that first square bracket that you see. It has these different components because, well, you might face a liquidity shock, you might not. But notice that what it's weighting is simply just the weighted value of that future, the value of that future income in the next late stage. Notice that doesn't depend, anything on the square brackets doesn't depend on the actual asset we're looking at, right? It doesn't depend on these omegas because we want to think about what's that expected lifetime value in the late stage across these different liquidity events, which means that if we forget about the bottom line, the second square bracket, it means that that the rate of return on these assets would equalize. Now we're going to find that these rate of returns aren't going to equalize, but it's only because that households are making different consumption decisions based on those liquidity constraints. And that's what the last line captures. Notice that if a household is constrained, what I mentioned before, if they're running into that liquidity constraint, the thing inside the square bracket is not going to bind, which means the value of what you want to consume early is not going to be equated with the cost of not having those funds in the late stage. What that term in the squiggly brackets represents is a liquidity premium, right? How much would you value having an additional amount of liquidity for that particular asset in order to finance this expenditure risk? And so as assets differ by how useful they are in terms of the liquidity premium is going to differ, which then is going to be reflected in differences in rates of return. Okay? So I know that it looks kind of complicated. Hopefully that made some sense. But the key thing here is the only reason we're getting rate of return differentials is because of liquidity. And that's going to be an important way we try to think about either disciplining our model in the calibration or finding some non-targeted moments to look at. Okay. So the last thing I want to get to the quantitative part, the last thing I want to make sure I emphasize is in that late stage, as households are choosing this mix of assets, what they're considering is really balancing the need for liquidity from these expenditure shocks versus balancing the need to have a higher rate of return in order to precautionarily save for the future. Right? So in that way, households to some extent specialize. If, say, they're facing a higher unemployment risk, then it's natural they're going to want to save more in terms of the less liquid, higher return assets, because those assets are perfectly liquid in the late stage, and they have a higher return. So you're able to save faster. Of course, they're not useful in terms of liquidity, so that's what balances the need for these two things. Okay. If I close the model really quick, I don't want to spend too much time on this. This is the supply of houses. It looks very similar to the supply of firms. We can think about, there's some agents that create houses. There's free entry. The value of creating a house is going to be high, the price of that house, PH. And then there's some exogenous depreciation of houses over time. And then there's some endogenous discount rate for what the value of the future flows, income flows of producing this house and selling it are. A free entry condition that yields some relationship between the price of the house and in this rate of return. Okay. And last, government budget constraint and market clearing. Here's what I mentioned about before. We have a consolidated government budget constraint. The value of their transfers or taxes must be equated with either the amount of money creation that's happening. Right? M is this exogenous sequence of the stock of money. Phi M is the real value of those dollars being created. And then the government has to finance these interest rate payments on their debt. Okay. So again, our G is endogenous, the phi is endogenous. So you get some feedback of one, money creation might feed back into the government budget constraint through this rate of return on government bonds. And then we need to clear every market. And that's it. Okay. So let me talk about the calibration and then I'll move on to the experiments. So first, at a very high level view, what we're going to want to be consistent with is one, how we calibrate most labor market models to match things like inflows and outflows. That's going to be relatively standard. So we're not going to try to innovate too much on that. The part we need to innovate on is how do we capture this need for liquidity, right? How do we capture how households are responding to changes in anticipated inflation or safe nominal interest rates? The way we're going to do that in this paper is that we're going to take quite seriously that these are expenditure events, meaning we're going to use data that asks households about unplanned expenditures in the previous months or quarters. The survey, which I'll talk about, is going to ask them, it's not the survey of consumer finances, it's going to be a different survey. It's going to ask them, did you have any unplanned expenditures? How large were they? How frequent do these happen? And that's going to map essentially one-to-one into disciplining what that looks like in the data. So these are, as I'll mention, these are things like medical expenditures, car repairs, divorce is a big unplanned expenditure. that's going to generate, really the need for why households are holding money in the model. And then using the survey of consumer finance, we can map these different categories of wealth from the data to the model. We'll do that. I'm going to assume that bonds, financial equity, and housing all have the same, bonds and financial equity have the same rate of return in the model. So from the household side, those are going to look indistinguishable, right? A share of a mutual fund versus a share of a treasury bond. Those will be the same. That's going to be by assumption. So I have some illiquid financial wealth, some illiquid housing wealth, and some liquid money, which we'll see in a minute. Okay. This is a labor market. It's pretty standard. Let me not, mention too much about that. In terms of the goods market, we want to capture that firms have some market power of producing early. So we're going to try to set the curvature of their production function possibility frontier to capture a markup, which the markup here would be over their cost. The cost is in terms of not producing as much of the late good, right? So it's a relative cost of I produce more today. How much can I sell over the cost of the opportunity cost of not producing later? We're going to match that to a markup of 30%. Of course, if firms didn't have any markup, they don't care about this aggregate demand channel because they go and produce and they're given, essentially their outside options. Okay, here's how we map assets. So you want to think about money as essentially zero maturity wealth. These are like essentially transactions accounts, checking, saving, money market, etc. Housing is going to be the net worth of directly held, that's directly held in residential structures. I'm also going to include durables, right? Even though that's a very small fraction of total household wealth, it's going to also matter for this distribution, right? Because many low wealth households still have some durable wealth. That'll go into housing here. Government bonds will be direct and indirect holdings of financial wealth and bonds, and firm equity will be direct and indirect holdings of publicly traded stocks and directly held business equity. So if you own your own company, the survey of consumer finance can capture that. The difference here is, that return is not, traded in the market. So what we're implicitly doing in the model is assuming that follows the same return of publicly traded equity. There's sort of nothing really we could do there. Okay, so what I'll do is I'll set parameters to match, how costly is it to hold these transactions accounts, which will be that there's a negative 1.5 average real return on holding transactions counts. And then what I want to do is we're going to calibrate the level of government bonds, the level of firm productivity, labor productivity, Q bar, and the entry cost of housing. What these do is they're essentially supply parameters across these other three different types of assets outside of money. And so by disciplining supply, we're going to also try to capture, some notion of the quantity of what of these assets that households are holding in their portfolio. So what are the moments we're going to try to target? We're going to try to target that households hold 40% of their wealth and of their financial wealth in bonds relative to equity. Why is that important? Because we're assuming that the government bond supply is fixed here in the long run. So as money creation and inflation are changing, that's only going to affect the return on that financial wealth as a function of how much of that financial wealth is stocks versus bonds. And we want to try to be consistent with that. We'll match median financial wealth to income and also median liquid wealth to income in the data. Okay. Here's the expenditure risk I mentioned. The survey I'll use is a survey conducted by Pew. It's nationally representative. It's not a large survey. It's only about 4,000 households that are asked. And they ask about, again, unplanned expenses, out-of-pocket things like out-of-pocket medical expenses, home car repair, divorce. Here's the numbers. Here's the takeaway. About 53.2% of households experience a shock in the previous year. What that maps into in our model is that on average every month, the probability of getting an expenditure shock is 6.1%. So these are relatively infrequent shocks. You need this liquidity relatively infrequently. However, when you do, it's relatively a large expense. The median expense in the survey is $2,000. that's going to pin down the level of that utility function of how much they want to consume early. And so we can map the median expense to median income, which is then going to map into that level. I'm going to set the elasticity parameter of that of the utility for early consumption to match the money demand, the empirical money demand curve. So the fact that as inflation increases or nominal interest rates increase, money over GDP is falling. Okay. All right. Last thing about the calibration, and then I'll get into the takeaways. Of course, again, the key difference is not only how often they need to rely on this liquidity for this expenditure risk, but how can they use these different assets to insure against that, to finance that. Here's how we're going to do it. I'm going to think there's only 3 different types of resaleability events, right? Either you could only use money, you can't use any of your other wealth. You could only use money or housing, your housing equity, or you could only use money in your financial wealth. So you can see there that money, I'm going to assume, is always accepted. You could always, use that to finance consumption. However, housing and illiquid financial wealth, again, they're going to be relatively less liquid. How we're going to discipline how frequent that is, this alpha MH is going to be the probability, conditional on getting an expenditure shock, that you're able to use your housing equity on top of your money. I'll match that to the fraction of households that I observe withdrawing from their home equity, either through things like home equity lines of credit or cash out refinances in the survey of consumer finance. That's relatively a small fraction of households, 15%, and that'll capture that resaleability event. I'll do something similar in terms of financial wealth. I'll look at the survey and ask how frequent households withdraw from their retirement accounts. I can't observe direct sales of financial wealth, so this is going to be a bit of an underestimate of how liquid financial wealth is. And so, importantly, what does the calibration deliver? If this is how we interpret these liquidity events, it implies that money is the most liquid. Housing is this middle asset that's more liquid than financial wealth, but less liquid than money. And financial wealth is the least liquid that households have. Okay.
And Zach, I got a silly question there.
Yep.
About so is this withdrawing home equity? Does that mean opening a HELOC, or does that mean withdrawing from it? Because suppose I have the line, I might withdraw at any time. So do you observe the withdrawal, or do you observe the opening of the account?
Yeah, we see how much you withdraw. It's withdrawals, how much you use on these home equity lines in the survey of consumer finance. Yep. Okay. So the first thing I want to do is ask, does this model, so in the calibration, we haven't targeted any cross-sectional facts from households, any elasticities at the household level. And so we want to ask, to what extent is the model consistent with these untargeted cross-sectional facts of households, either in their portfolio composition, how they respond to shocks, things like that. Let me first show you the household portfolios as a function of their total wealth. Again, from the household point of view, there's now 3 assets, either liquid, housing, or this financial assets and equity and bonds. And what I've done here is showed you both in the model for employed and unemployed, that's the red and the blue dashed lines, and also in the survey of consumer finance data, that's the green dots, how well does the cross-sectional portfolio shares match in the model to the data, okay? So first, let's think about the share of liquid wealth. Here, the model does very well. What does it capture? It captures, one, this broad pattern that if I look at higher percentiles of the total wealth distribution, households start to hold more financial wealth, less liquid wealth and more wealth in housing and financial assets. The households that are at the very bottom of the wealth distribution are holding they're holding their entire portfolio in money, right? So they're not using any illiquid wealth here. That's also consistent with the data that we see. We get some differences between the employed and unemployed. Once you get above about the 25th percentile of wealth, those completely go away. You're wealthy enough, it doesn't really, liquid wealth kind of becomes less important. But if you're very poor and unemployed, you're going to hold even more liquid wealth. You're even more concerned about this expenditure risk. Why is that? Well, if you're employed and very poor, now you have 2 things to worry about. You're going to lose your job, so you need to precautionarily save. that means that you're going to hold back from holding some of that liquid wealth and hold things like claims, bonds, et cetera. Okay. Now, where the model does not do well is matching the level of how households are holding housing assets, housing equity versus financial assets. Because housing in the calibration is this sort of middle asset. It's not the best for precautionarily saving for unemployment risk because its rate of return is in the middle, and it's not the best for liquidity. It turns out that households in the model just don't hold that much of it. They still hold some, but not that much. That's the left panel. The rest they hold in financial wealth. So we're over accounting for how much financial wealth, under accounting for how much housing wealth. That we don't think that really is going to, impact too much our results on the neutrality of money, the longer neutrality of money. But of course, it's something we're trying to deal with in certain ways.
Zach, so apart from the shapes, just the level, why can't this be fixed just by having a higher stock of housing in the model? And the share of aggregate wealth will be higher and the share of everybody's wealth will be higher.
Because basically what happens is now you distort the total wealth to income level. We want our model to match, the median wealth to income. You distort the portfolio shares that the average portfolio shares we're trying to be consistent with.
So you're saying you're matching the average portfolio shares, but for almost every percentile, portfolio shares are off. That's a little weird.
So what you're kind of thinking about is you want to affect the supply of housing. The way you do that is affect this cost of creating houses. It means you have to give up one of these three moments to do that, right? So either you give up kind of, on average median wealth to income or financial wealth to income. One of these things has to go. Now, again, we're a bit limited here, right? We have 3 moments. Sorry, we have 3 parameters. Ideally, you'd like to target, all these different features of the wealth distribution and portfolio shares. We just don't have that much degrees of freedom to do that. That's the easy answer. But we can certainly think about, relaxing this assumption that to consume housing, you don't necessarily have to own any, live in any housing. There's much more sophisticated ways on the housing side to improve this fit. I'm not sure we're going to take the paper in that direction, but clearly we're missing out on this model, on that dimension. Okay. What I want to ask next is how well do households, does the model capture how households are responding to the rate of return, changes in the rate of return over time of either the rate of return of money, liquidity, or the rate of return of financial wealth. This is a figure that shows you what the elasticity of, what I'm plotting is the household's share of liquid wealth, how it responds to these 2 different interest rates, right? So the blue is capturing, if I increase the rate of return on money, how does households shift their share of assets towards liquidity, towards money? That's obviously positive, both in the model and the data. In red is, what about if the rate of return on financial wealth increases? How does that change their liquid share? That obviously negative, it decreases it. So we get the sign right. That's kind of the first check. But more importantly, we're pretty consistent with the cross section that the households responding the most to relatively longer run rate of return changes. This is things over, we do like 5-year horizons. We're broadly consistent with the households that are responding to most do tend to be the households that are coming from the bottom of the wealth distribution. Right? The elasticity of very wealthy households in the survey of consumer finance, and to some extent the model, is essentially 0. It's very low. The agents that are responding the most, again, are like the agents in the 10th, 20th percentile, around there. Okay. So the reason it's important to be consistent, to have the wealth distribution in the paper is inflation is going to affect all these rate of returns. That's the mechanism for what's generating this Phillips curve. You have to be consistent with how many, the elasticity is how many households are sitting in this, these different percentiles of wealth, right? What's the shape of that wealth distribution? And it seems like our model is capturing that well. Okay. All right, one more, then I'll kind of end on the key experiment. So I've showed you we're pretty consistent with the portfolio shares, the responses of those shares with respect to interest rate changes, return changes. Now I want to think about how well the model is consistent with how households are insuring against these 2 different types of risk, right? The way to think about that is I want to look at how well the model does in matching household MPCs from unanticipated transfers of liquid wealth, how households are responding to job loss in terms of their consumption. What I'm showing you in the figures is what the model is predicting. So first, looking at the MPC, we see that MPCs are falling in total wealth. They're higher for the unemployed. The average MPC in the model across all households is 18.7%. Again, we don't have any transactions cost here, explicit transactions cost here. But because of this acceptability and liquidity differentials, it's giving you an MPC. Of course, in the data, we get big ranges, but on things like non-durables, we're about in that range, 12 to 30%. We're also consistent with the data that MPCs are falling with wealth or higher for the unemployed. Quantitatively, our MPCs fall pretty quickly in wealth compared to the data. Again, we're getting a lot of action in like the 0 to 20th, 30th percentile of wealth. Once you get above that in the model, you're very well insured for both types of these shocks. Our average consumption decline upon job loss is 7.7%. In the data, that's a little low. It's usually between 9 and 16% on average. But notice what we have is that unemployment risk is really large for households at the bottom of the wealth distribution. Again, once you save enough, your consumption response is consumption is responding relatively little to the job loss. Okay. So now let me get to the experiments. Okay, so Lucas, I have 15 minutes, I think, give or take, maybe a little less. I think I started early. Okay, so here's the effect of inflation, first on prices. What we see in the left panel is that as I increase inflation, right, I'm reducing the rate of return on money. We have this Tobin effect that households are shifting away from liquid balances towards less liquid balances, including financial wealth. And that's going to reduce the rate of return on financial wealth. I've plotted some data here. This is, again, trying to do some like long run comparison. I've just plotted the raw data, the relationship between annual inflation and some measure of return on financial wealth, trying to take out aggregate risk, because we don't have aggregate risk in the model. What we see is that we get the sign right? Inflation decreases the rate of return on firms. That's no surprise. The model is somewhat underpredicts the magnitude of how that's adjusting, but at least for low inflation rates, it's pretty consistent. We also match the fact that it doesn't look like the rate of return on housing is moving that much with inflation, right? If you look in the data, we get somewhat of an effect in the model, but again, it's relatively muted. Okay.
I'm sorry, Zach, remind me again the period
Here's the punchline.
And the data.
What's that? Annual.
Remind me.
It's all. Yeah,
no, I mean like which
data.
what's the what's the time frame?
In what do you mean?
Like this post-war, 1970 onwards.
Yeah, post-war. No, like 19. Yeah, it's a good question off the top of my head. I think it's 1955. If I'm right.
I mean, if housing is liquid, you should get something negative, and you do in the model. And I've seen in my data, I got it negative, but of course, that's why I'm asking, what's your data? I can look it up later.
Okay, so I don't, for the housing data, I don't remember how far back I observed the rate of the return on homes. Yeah, maybe we can talk afterwards. Yeah, good question. Okay, but again, it is negative in the model. The magnitude is very small. Elasticity is pretty small. Okay, so here's our long run experiment. I'm gonna think about this in the lens of the Phillips curve. Although the causational direction in these models is flipped a bit, right? If I change inflation, has the unemployment rate change? But in that sense, again, we get this vertical long run Phillips curve. There's a lot of lines there. Let me explain quickly. The blue line is a linear fit of a scatter plot of the data. Again, annual data on annual inflation and annual unemployment rates. You could try to filter this in different ways. Essentially, you get that there's a pretty muted relationship. It's slightly positive in the data, but it's pretty close to being vertical. The green is the general equilibrium model. We also find a slightly positive relationship. Again, this is not targeted. We nearly match what that best fit line is in the data, almost no relationship. But again, it's masking these two large aggregate channels. The red line is showing you the channel only if this interest rate effect is operative, right? how can I do this? I could just take the firm's free entry condition, the job creation condition. That's what I have at the bottom. I can map tightness into unemployment, and from how to get tightness, I can map that from the price of early consumption. That's capturing the aggregate demand channel, and the rate of return on firms. If I only allow the rate of return on firms to fall, that's going to increase unemployment. Decrease unemployment as inflation is rising. We get this negatively sloped Phillips curve. That's pretty strong in magnitude. Again, essentially for long run unemployment, to explain long run unemployment. We get almost the equal but opposite channel for the aggregate demand effect. And you say, okay, well, does it matter that all these channels, are offsetting? It turns out it certainly disciplines what the welfare effects of inflation are. And I'll kind of end here because I think I'm about out of time. Here's the welfare cost of inflation. In the general equilibrium model I'm showing you on the left-hand side. Right? So first, what we see is that the welfare cost of inflation is decreasing pretty consistently until about 5% annual inflation. Right? We need to add more data points here. But around 5%, that's when we see a turn. Any inflation, from the Friedman rule, this is consumption equivalent inflation cost measures, is welfare improving in the aggregate. Once you get beyond that, then the kind of standard channels take over that inflation taxes liquidity so much it's harming welfare. Now, where do we get these positive benefits from? We do a decomposition that's sitting in the right-hand panel of these different channels. And the way I want to think about different channels in the model is through these different price effects. So the direct channel, this includes things like transfers, by the way, this includes only changing the rate of return on money, keeping all other prices given. This is the standard inflation tax channel, setting aside all these other parts. We find that leads to a purely, welfare reducing inflation away from the Friedman rule. If that was the only concern, we'd want to run the Friedman rule in the long run. However, once you start including these different assets, particularly housing is giving us a big effect in the model. What we find is that generates these strong positive effects, right? And the reason that these positive effects is of inflation and through the asset market, asset prices are getting more expensive. That's harming them. But now firms are entering, that increases unemployment, that reduces the need for precautionary savings in the first place. And that counterbalances it. And that's the reason why having this endogenous, endogenous unemployment risk is important in the model. You could ask, I said I did, let me do one more thing. You could ask who wins and who loses in terms of inflation. This is looking at, I believe, 5% welfare cost of going from the Friedman rule to 5% inflation. What this shows you is breaking up that welfare cost by the percentile of total wealth, households and percent of total wealth, either employed or unemployed, or the average. That's the green line. So focus on the average. What we see is a U-shaped pattern in the welfare costs. In fact, 5% inflation, as I suggested before, is beneficial relative to the Friedman rule for most households, except the very wealthy and the relatively unemployed. Okay. Now, the reason we're finding this is it's partly offset by the fact that inflation is increasing these asset prices and increasing job creation. However, because the unemployed now are focusing more on liquidity because they're using their precautionary savings already, now they're also more can be affected more by the inflation tax on their liquidity. That's why we find that the effect on unemployment is slightly higher. Okay, so I believe I'm out of time. Let me just quickly summarize. We're interested in the long run effect of inflation on unemployment. We find consistent with the data that it looks neutral in the long run. However, our model, which is consistent with a lot of important, household level cross-sectional facts, suggests that the reason it's neutral in the long run is that you have these different channels that are offsetting each other. What it doesn't mean is that inflation is neutral in terms of redistribution, right, across the household wealth distribution. That's essentially what I discussed at the end. Okay, thank you.
Thank you, Zach. More questions? I'll ask about the the welfare results. So I'm quite surprised that you said that it's all coming from housing. Because I would have I mean, the part where the higher inflation causes job creation through higher asset prices, that makes sense to me. And that's what I would have expected to be responsible for the positive channel. But you said that washes out against something else. So why do we keep having this? Is it, what's pH again?
Yeah, so let me just quickly describe the experiments because I showed this pretty quick. What we're doing here, and it's not clear this is the right decomposition to do. It's the one that made the most sense to us to start. The baseline includes everything, right? All adjustments in asset prices, how those asset prices are affecting government transfers, how those transfers are affecting household decisions, you know, on and on. The decomposition is the following. Take the realization of given this change in inflation, how it's affecting these different prices, how it's affecting the rate of return on money, that's immediate, direct, how it's affecting the rate of return on firms, housing, and the price of early consumption, right? And then feed that into the model, just keeping fixed the other asset prices, but allowing things like transfers to change, tightness to change, you know, the free entry condition to respond. So as an example, assume it's just the inflation tax, the blue line, right? RM is changing, but I'm leaving fixed the price of the market value for firms, housing, and early consumption. What's still changing in the background are things like transfers, for instance, right? And so one, we get a positive welfare cost there, but notice it's pretty small, right? I mean, 10% annual inflation only gives a welfare cost of about, you know, less than 0.1% of consumption. Why is that? Well, that's simply, you know, due to the fact that inflation is redistributive in the model because these are lump sum this is helicopter drops, right? So if you do helicopter drops, that's going to improve welfare at the cost of distorting liquidity. It turns out distorting liquidity is more important than redistribution, but the welfare number is much lower, right? You kind of see that across these different objects. The reason I say housing is more quantitatively important here is simply, you know, if you look at the decomposition, the question I'm asking is, why do we get such a large optimal inflation rate of around 5%, right? That's much larger than we typically find in these models with different externalities and stuff like that. And it works through this housing margin by changing the rate of return on homes. And if I can go way back, essentially what it's doing is it's decreasing the rate of return on homes. Let me state title figure. Right. Decreasing the rate of return on homes. Decreasing the price of homes. It's making that rental price relatively low. In a welfare sense, that's positive for households. It doesn't distort any of their transfers, right? Governments don't have to tax more to finance that, you know, changes in that rate of return or less, and that's purely a positive welfare benefit on the side of the households, right? And quantitatively, that's just giving us a big kick in this welfare cost.
Okay, well,
there's a lot going on behind all these things. Yeah.
But let me yield to Rob and Bob and Giannis first.
So I like this new monitor stuff because in these kinds of models, you can really see who's doing what and how things work through. And I think that this is a really nice model in some ways of the demand for liquidity and the interaction between the liquidity sector and the rest of the economy. I expressed before that I was less sure that it had to do with inflation, but we can agree to disagree on it. Now, one thing that seems really striking to me is how bad screwing up liquidity is for the poor people in this economy. And sometimes people argue that policies that essentially produce a low real return on liquid assets are desirable from the standpoint of the poor because they let you stimulate aggregate demand and then there are jobs, right? But in your model, it doesn't look like that's the main thing. If I were a poor guy in your economy, I don't think I would like low returns or high inflation very much. And so I'm kind of surprised I mean, it would seem like the welfare weights must matter a lot in terms of deciding what the optimal rate of inflation is. So those are my reactions to this. I don't know how many of them are correct.
Yeah, no, I mean, I think I think you're right on line. I mean, we want to be a bit careful when we think about, so notice this welfare cost, the very, very poor are, you know, the households that win the most from inflation. This is the welfare cost, right? So a negative is a positive. Because this is a helicopter drop, right? I mean, essentially a helicopter drop is a progressive tax, right? It's a progressive transfer. We're giving everyone the same amount of money, regardless of your money holdings. I think, you know, that's the experiment we're kind of starting with. I think what you'd really want to do is think about something like a proportional transfer, right? Something with your wealth. The helicopter drops give us this big redistribution, right? It's a little tricky because households aren't, you know, there's two things that are kind of going in opposite directions. So one is, if I just give out money, you know, lump sum, that's going to disproportionately help the low wealth relative to the high wealth. However, it's going to generate inflation in the long run, right? And because it generates inflation in the long run, that's disproportionately affecting who? Well, also the poor. Now, we can ask in this model, which one of those is winning out to some extent? And in terms of welfare, who we find gains the most from that, from just the fact that we're doing helicopter drops, are not the very poorest, but the relatively poor, right? 10 percentile, 20th percentile wealth distribution, something like that. And the employed, they win out the most. Now, who's hurt or, you know, wins out less? The very, very poor, which you see, you know, the green line goes back up. And then eventually the wealthy, that's more of like these asset price channels. So that gets at this idea that, you know, the fiscal side is really important here. If I just ask in the model, what happened if I just exotically change the rate of return on money? Right? That's like the inflation tax. And so change inflation without changing any transfers, right? Some like partial equilibrium experiment. Your intuition's right. The poor lose, the unemployed lose. It's because that they're really exposed to this inflation tax channel, right? Now they're helped somewhat because of the, like you mentioned, because of the unemployment risk dimension. But how you finance that is really important. If you do helicopter drops versus like lump sum, versus like you know, you could, you know, potentially use money creation to finance unemployment benefits, things like that. Right, that's obviously now redistributing those money in different ways.
Reality, with I mean, the simplest mapping between reality and your model I can think of is that we retire government bonds. So I don't know how wedded you are to this rate, this 40% being fixed, even across the experiments. I guess we can ask, okay, what if we increase inflation?
Yeah, no, the 40% isn't fixed. Yeah, the 40% what Lucas is talking about is we're trying to capture the fact that households hold about 40% of their financial wealth in bonds. Of course, though, that, you know, once inflation's changing, all those portfolio shares change. I mean, that's one kind of, you know, this is our first project and hopefully a long line. I mean, what's really interesting is now in these models, you can really ask all about the government budget constraint, right? You do things like, you know, open market operations or different types of, you know, changes in fiscal policy, stuff like that. You know, we could use kind of all the interesting, you know, things that we've studied on that side, and then just, you know, on the household side, use this framework to understand the effects of that stuff. But yeah, I think what the place we are now is that the model is nice, but it has so many channels. We're really trying to really disentangle what's happening across these different channels to get a consistent story. But yeah, thanks.
Hey, very, very nice. I've seen it a couple of times already. I really like it. Can I ask you? It's a bit technical and boring, so maybe we can talk later. But is it? So the machinery to use it, so the nice thing usually with this, the liquidity you monitor is models that are very tractable. We always have the CM, you know, pretty much we characterize all of stuff analytically, solving stuff boils down, you know, to steady state analysis. Here, have you used the machinery from the, you know, the IAGARI kind of models? That's how you go, or in some sense you can break it, and for each asset level, it's like you're solving a new monetarist model. Can you comment?
So it's a good question. Let me say first, here it's long run. So there's no real computational complexity with dealing with the long run without aggregate uncertainty, right? I mean, we basically can solve the household problem, you know, without knowing the distribution, right? Also, it's all competitive here. So tell me the prices, I solve all the households problem. I don't have to worry.
What about job creation? You don't have a job creation condition in which if you meet different people with different assets, this is going to matter?
No, it's competitive, right? Yeah, a job creation, I go and supply my goods to the competitive market. I take price. Yeah, so we're really relying on the competitive market stuff. But you know, even if we didn't, but even if we were to do that, it would complicate it. But in the long run, it's not so much. Where we're going now is to ask about, you know, what I think Bob would agree maybe is more about inflation. It's about really like short run impulse responses in terms of what if there's a one-time, you know, increase in the money supply or increase in the bond supply, things like that. Is that inflationary? How do households respond? You know, who is that impacting? That's kind of where the next paper is going. For that, then we have to deal with more machinery, the dynamics, because obviously in the standard framework, it depends on these expectations. The reason this model is tractable and even doing dynamics and even things like aggregate risk is, in fact, you kind of mentioned it before. Let me see if I could find it. We can treat it essentially like a Bewley model, right? And use all the tools of the Hank literature, these other heterogeneous agent models, which I could talk to you about offline if you're interested. The question is, how does all this liquidity stuff complicate the numerics, right? Well, actually, it's pretty simple, right? All you have to do is solve this problem at the bottom. But at each step of the, if you're trying to solve for what the Bellman equation is, for instance, this problem here is very quick. In fact, you can invert what your early utility function is and immediately get a policy function that tells me, if I could finance anything, what is the first best level of consumption that I would finance early? That's an immediate step in the computation. The second immediate step is ask, well, can you afford that consumption? That's the blue constraint up here. So computationally, adding in these liquidity constraints, et cetera, I mean, you can get pretty fancy with this. That doesn't affect at all how complicated it is to solve the model. Once you have that, then everything is like, it reduces down to just this one Bellman equation. And you could use all the kind of standard tricks that literature is.
So essentially, you're saying that at steady state is like solving a Bewley model, and liquidity doesn't add much other than the standard constraint of
even the dynamics. It adds technically one step into solving, even a dynamic, Huggett Bewley model. But that step, even though it looks complicated in these different liquidity, is immediate computation. Yeah, it's very fast to compute, is the idea.
Very good. Awesome. Very nice.
Yeah. Thanks, Jonas. Thanks for coming.
I got a roll. Thank you very much for an interesting presentation. Thanks again, Lucas. Take it easy.
Yeah, thanks, Lucas. Thanks a lot, Bob. It was great having you.